These two rivers give the name of the city Varanasi. As in the first session, we have heard many speakers. River Varuna is still in existence and it is visible. So, but then the last 32 kilometers near Varanasi, it is in a very sick condition. Primarily due to two reasons. One, this is not getting any flow for continuous running of the river. Whatever we see in the river, it is sewage. So how to meet the social obligations which we as an scientific community or engineering community we have towards the society. As I have been mentioning, and I keep repeating this, our Kulgeet of Banaras Hind University keeps us reminding सुरम्य धारा ए वरुणा अस्सी नहाए जिसमें कबीर तुलसी. And this has not been written by anybody else, not anyone. He is one amongst the topmost scientists of the world and greatest scientific leaders of the society, Shanti Swarup Bhatnagar, in whose name this Bhatnagar award is given in this country. So we simply trust these sentences and we have to come to the expectation of this society. IIT, BHU for that matter, and Banaras Hind University, we are obliged to work on that. We have to. So, what is the scenario? In a brief note for River Varuna and Assi, which I have shared with all my colleagues, I have given the description. What is the latest finding? Professor Raju is here. He has spent many years along with his team of researchers to find the origins and different aspects of River Varuna as well as Assi. He will be sharing his thoughts down the line during the discussion. So, our objective is that this Varuna river is still flowing. I have given some flow data as well, which is being observed by Irrigation Department of Uttar Pradesh. They shared with us some data. It gives that there is flow during some part of the year. For some part of the year, there is no flow in this river. When it comes down to near Varanasi city, as per Central Pollution Control Board's report, around 32 kilometers of this river, Varuna, is in critical condition. And through this critical condition, we mean there is no flow. And if there is a flow, this is a sewage water only. This is not worth taking bath. So I keep reminding my colleagues in the Department of Irrigation. A few years back, when Department of Irrigation was taking some initiatives on River Varuna near Varanasi, I was the head at that point of time, and I told that our objective is met only when one you and one me, both of us can take bath at river or at Shashtri Ghat of River Varuna. And this is the journey which we are making, and I'm still working on that. So the engineer in chief of UP Irrigation, Sri V.K. Niranjan Saab, is there. He is very much visible to me. I'm seeing him. He has joined. So he is a part of this discussion. And how we are going to meet this social obligation. Let us remind ourselves that rivers have been giving water to us. Today, in our family life, you understand, our parents rear up. But then here is a situation where we have ended up in a condition where rivers are in need of water. How to bring it back? How to make our river system really healthy and happy? So, we will be having our dedicated discussion following this keynote address session for 2 hours. And the experts belonging to hydrogeology group, we will be focusing how to meet this environmental flow. Environmental flow includes meeting the bathing water quantity requirement. And then there will be second group who will be talking on environmental quality or treatment. So with this small background, I would like to begin this session, and I will invite Professor Piegay to give his presentation, which he has prepared for us to help us in our situation. Before I really come to him, let me share with you a 6-member strong committee is coming in next February to Varanasi from our French consortium, the French River Science Institution, led by its director, Professor Harvey. And he is very much actively engaged with us. He is very much willing to help us in River Ganga Basin, as well as the tributaries which we are working on today, Assi and Varuna. So, welcome, Professor Piegay. Professor Piegay is a part of his team, and he will be representing him today. So, Professor Piegay, welcome, please.
Thank
to
you.
you now.
Thank you very much for this kind introduction, and thank you all for inviting me to present some thoughts that we have developed over the course of the years. Of course, I'm not knowing your river system, although I've read the the report carefully, and of course I'm not here to teach you how to sharpen knives, because you are the specialist of your systems. What I just wanted to highlight during these next 20 minutes is some of the perspectives and thoughts we had on river restoration and the way we try to address it in Europe, which is of course a very different type of studies. But nevertheless, I suspect that most of the elements that we are thinking about could be shared and adapted to your situation. So what I'm trying to do now is to share my, I hope it will work. No, that's not this. Sorry about that. Doesn't seem to, maybe I made the wrong thing. Let me try again. Sorry. Technical. I have a problem with the no. Should have tried earlier. Can you see it now? Can you see?
No, it is still.
Yes, I could see it.
Yeah.
Okay, and if okay. So you could see and you can hear me, because now I'm blind, I just see what I'm presenting. So I will try to keep within the 20 minutes. And I would like to thank my co-author, Hervé Piegay, who is the specialist of the geomorphology in large rivers. And I'm more specialized in water quality issues. One thing I wanted to start to raise, I don't know if you see the next slide or?
Yeah.
Yes.
Yeah.
Blue
Well,
and
so
gray.
okay. So this is a clear view of the Rhône River just downstream Geneva. Yeah, so I think if you could switch off your microphones, because I have some kind of feedback in my headset. All right. So just to start with, I would like to tell you what we are doing currently on the Rhone River, which is, of course, nothing to do like the Ganges River, much smaller, but at least for French size, it's a rather decent large river, which originates in the Switzerland mountains. And there has been a lot of research, mostly undertaken by many colleagues from the Lyon University, but also led by Harvey Piegay on that topic, where we were interested in how to assess the impact of the different tributaries on the water quality, and most specifically on the sediment load. And that's been deployed for over the last 10 or 15 years, a lot of field studies using different tools to try to measure the importance of these different sediment loads from the tributaries. Many different, as I said, many different tools have been used, different elements like the turbidity probes, the automatic samplers and particle traps, in order to try to assess what would be the repartition of the sediments and the associated pollutants to the water of the Rhone River. Basically, what has been found so far is that, of course, there is a partition of the different water quantity among the different tributaries, but also, as you can see in these two pies, quite different elements when you talk about water and you talk of sediment matter, with the tributaries being very prominent in delivering, especially the one coming from the mountains, in delivering sediments. So this kind of monitoring could really help us to assess the quantitative elements of this transfer of sediment. Sorry. This has allowed us also to see on a more spatial scale what would be, and temporal scale as well, what would be the associated pollutants which were transported with the suspended matters of the different tributaries of the Rhone. And there's been a lot of modeling exercise to try to assess that. But in order to be frank with that, I mean, it's a very necessary element of the monitoring, but that gives only a kind of a snapshot of what's going on, and it doesn't tell us what shall we do in order to improve the current situation. And of course, there's been also a lot of modelings going on with the importance of tributaries, and especially on the physical side of it, of how the tributaries could merge, how do they mix the sediment, how long it takes for the sediment to be well mixed within the river reaches. So many of these models have been developed over the decades, mostly by hydraulic specialists. But interestingly, this hasn't been very much, these tributaries and their confluences haven't been addressed at all over the last 50 years, where ecology has set up a few concepts. And one of them that I'm showing here is the river continuum concept, where basically people were, over the 1980s, trying to assess the importance of that longitudinal path on the functioning of the streams, regarding the impact of the size of the stream on the primary production and the nutrient cycling in the stream. But they were mostly interested in the longitudinal transfer of these elements rather than the importance of the confluence. At the same time, there was a second model which was developed, which was called the spiraling concept, which was interested in the sediment transfer and their fate along the stream network. And this spiral is a kind of example of how a nutrient element would be transferred from upstream to downstream and recycled over time. But here again, no mention to the confluence impact on these biogeochemical elements. So what I would like to just address over the next few minutes is a few elements which we started to to think about with Hervé and other colleagues on how we could try to understand what's going on within this river system and trying to assess where is the right place to start with. And one thing I would like to share with you is that it's a Romanian proverb saying that a staircase sweeps starting from the top. And basically by saying that, as you all know, the river system is really fractal. And that means that there is a lot of small streams and tributaries, which would then feed to the larger one. So in other words, what we are doing at the moment, we are often very much challenged by large stream water quality like the one you are talking about today. But we tend to forget that these large streams have been generated by very small ones. And those very small ones so far haven't been very much considered for many different reasons. And one of them being that there are too many to be tackled. And as an example, just as you know, I'm sure you know that these streams are very important. These small streams, for instance, in one of the Garonne River, which is one of our French rivers, basically 50% of the drainage of the catchment of the Garonne is made of stream order 1. And if you go to stream order 2 or 3, you get up quickly to 80% of the catchment. And this is true for most of the rivers, as you probably know. While the very large rivers basically do not really contribute for much of the length of the river system. This being said, nevertheless, we have a big problem. And as I just said earlier, is that the fact that there are so many has somehow puzzled our managers. And if you look at the strata number of the stream in France, which are the red bars, and in black, the number of sampling sites within the Water Framework Directive, a EU directive which is applied in France as well, you see a big discrepancy between the sites which are measured, which are mostly the stream order 3 and 4, while the stream order 1 are almost unknown, to the point that one of my colleagues, Kevin Bishop from Sweden, had written a paper in the early 2000s saying that these small streams were the aqua incognita. And this is really true, is that we don't know much or even nothing about this small stream. And yet we are pretty sure that these are the sites which are very important to start to tackle because this is where the water quality is getting generated. And as an example, we made a study which is probably known now for different areas, is that when you you look at the drainage catchment on the x-axis and the normalized concentration that you find in the different tributaries, you see that kind of a funnel shape, which somehow shows that basically the variability is within the small streams. And of course, this had led to a lot of annoyance by the managers, saying that they're so variable that we cannot measure anything everywhere. So we concentrate on the other side of the funnel. But the problem is that it's very difficult then to try to deconvolute the information you get in the larger catchments to understand what is creating or generating that average concentration. And this is very different if you look for nitrate concentration. This is like the green dots that you can see there, or if you look for DOC, where you see that the funnel shape is slightly different. So a big variability of these small catchments, which in fact is due to the fact that at that scale, of very small scale, there is a very good relationship between the structure of the catchment and the quality of the water which is flowing downstream. So in other words, from measuring key small catchments, we can try to assess what are the contributing elements to the water quality in the downstream part of the catchment. So this is something we published in Ecology Letters 4 years ago. But this is a key issue, is that trying to relate landscape structure and water quality would then allow us to try to reform or transform the landscape structure of the most contributive areas in order to improve the water quality downstream. And the good news that we got from our same study is that we measured on several catchments which were monitored continuously, we compared that to a snapshot measurements taken at different seasons, low flow, reconnection, high flow, or disconnection, and tried to assess if there was a relationship in the rank of the water quality that we observed from long-term monitoring versus snapshot. And we realized that both during low flow and high flow, that you can see in two of those presentation on the right side of the slide, there is a very good correspondence between the rank of the water quality we could find along a long-term monitoring versus a snapshot. So in other words, using a snapshot measurements during low flow and high flow could allow you to find out within the different tributaries which ones are the most contributive to your system, and then allow us to try to make some improvement of those which have the highest leverage on the water quality overall. And this way, it's a way to separate the ones which are at stake to the ones which are less contributing in order to rank your priorities in management effort. The second thing I would like to just mention over the next few minutes is that using a quote which I like very much is, if you come to a fork in the road, take it. If you know baseball, you probably know Yogi Berra. And I would apply that to the conference, and I'm back to the title of the paper I gave with Harvey, is that we somehow disregarded the importance of the conferences on the stream network structure, but also on the water quality within the stream network. In other words, we tried, and I tried for most of my career, to get away from these conferences, having in mind that they are very complicated. Yet, if you look at small catchments, they are everywhere. Every single kilometer, you would get one branch or another joining the main course. So basically, the question is very simple: is these conferences, are there sample mixing, or they are providing something different due to the fact there's a lot combination of different water quality, different water quantity, which might affect the biogeochemical cycle of the overall catchment. And this is the elements that we are working on in the last four or 5 years now, to try to understand what's the importance of those nodes within the river network in the water quality of the system. And we use the stream metabolism to try to assess the overall functioning of the stream. And I'm sure you all know what is the stream metabolism. Basically, the balance between respiration and primary production, where you have primary production in summer, and during the day, and during the night you have mostly respiration. And basically, this is a very simple element, which was already demonstrated by Yodum in the 1950s, but unfortunately we didn't have really the tools so far to measure continuously the oxygen concentration in streams. And now we use, and I make some kind of advert, although I have no interest in that company, but just to tell you that these OBO sensors are very useful to measure continuously the oxygen concentration in streams. And based on that, there is the graph here showing the diurnal variation of oxygen. We can look at the dire range on one hand and the maximum daily deficit, and that would produce through calculation the gross primary production of the stream, as well the ecosystem respiration. And we use these two proxies, these two processes, in order to see what could be the impact of the confluences on primary production and ecosystem respiration. We tested that on about 40 sites in 5 different watersheds in the upper part, not on the Rhône, but on the Loire River in the middle of France. And basically what we found is that we had what we called hotspot of functioning, which was very far away from what we would expect just from the mixing point of view. And if I take these two examples, just to show you some what we found. So on the left part, we get one of the tributaries, where you see that the dashed lines, the green and the red, are the true tributaries merging, and the blue line the blue line is the resulting of the mixing of the two. And what you can see is that basically the downstream max is within the upstream range, but the downstream minimum is below. So that means that probably nutrient pulse from one of the tributary would stimulate the respiration far beyond what we would expect it from only a mixing of the two. On the other hand, there is another example of another tributaries mixing where you, on the contrary, you see that the primary production, again, the dots, the green and the reds, are the two tributaries oxygen concentration variation over time, and the blue line is the mixing. And you can see that the mixing is far above what we would expect to be within the range of the two green and red dot lines. So basically here, the downstream max is above the upstream range, and that means that there is a kind of a increased of primary production, most probably due to the confluence effect, due to the widening effect, and then the less shading and more light for primary production within that site. So with these two examples, I wanted to highlight that the importance of these nodes within the network, which were very important. And if we combine all together a rather complicated slide, but I would try just to show you what is important, is we try to see what would be the over the 40 sites that we measured, the percentage of days where the downstream daily maximum of oxygen. And if you look at the gray, the gray part, the gray part is that it's within the expected range. And if you're on the green or on the black, you're either above or below the upstream range. And in fact, over these 40 sites, we found that about 75% of the time, we were over the expectation of the simple mixing. So that means that these mixing zones of tributaries are very important. And this is something that we didn't put in place, especially during our monitoring issues, because we were expecting only a mixing for the sake of simplicity. But nevertheless, these mixing zones are key places, and probably key places also for restoration if we want to enhance one thing or the other. So I didn't want to take longer of your time, but just don't forget to take home message. The first one is that sweep the staircase from the top. So that means if we want to really have a long-term improvement of water quality, we have to start from the upper part of the catchment. And we are now have tools or some data which somehow helps us to have a strategy for sampling the most important part of these subcatchments in order to have a higher leverage on the water quality downstream. And the other take-home message is when there is a fork, take it. So that means don't forget to use also these nodes as key places for monitoring in order, and also for restoration sake, in order to improve the water quality within the drainage basin. And with that, I thank you for your attention and happy for questions.
Nice. Thank you, Professor Piegay. Wonderful, wonderful presentation. I mean, you have given a very insight description about the gross primary productivity as well as the nutrient pulses. This concept is very much useful to us in river Varuna, where two tributaries are meeting, Basin and Morwa. And nutrient pulses, we are, trying to understand how the river health is getting affected due to that. Moreover, when it comes to river Assi, which we will be discussing tomorrow, this mixing and its outgrowth, that which is our plan to, when your team is visiting India, our plan to correlate that with river Ganga. So that aspect will be very much useful to us there. So thank you very much for a wonderful presentation and giving us a concept related with this understanding the catchment and then its effects on the downstreams. So nice of you. Thank you. You are a part of, our
I don't know if
Sound is
it's
gone. Good.
yeah. Anyway, thank you for your attention.
yes. Hello, I'm audible. Yeah. Following that, we have another presentation by a very dynamic person. I know him since a few years, Dr. Victor Shinde. He has worked thoroughly on river health aspect, and currently he is working with the government, the effect on rivers near urban areas. So, Dr. Victor, very much welcome. We wish to hear from you. What are the plans of river health management near urban areas? Because our rivers are getting threatened or getting challenged near urban areas more than in the suburban or rural areas. So, welcome and to you now.
Yes. Thank you. Thank you very much, Prabhat sir. And then it is, and at the onset, let me thank everybody, for being here in this wonderful conference, and especially to you, Prabhat sir, for organizing this conference. I was also part of the previous RHAR, and the insights and the discussions that we had 2 years ago. I'm looking forward to those kind of discussions here as well, right? Although it's in an online medium, but I think the ethos, the spirit is very much the same, right? So like Professor Prabhat said, I work with the National Institute of Urban Affairs, which is the think tank of India's Ministry of Housing and Urban Affairs. So essentially, our job is to help the Urban Development Ministry in coming up with policies, in coming up with strategies related to the development of our cities, right? And since I have a background in water and environment, so my job essentially is revolved around sustainable development in our cities, right? So in the quest for economic development, sometimes the environment takes a backseat. So through the actions that we do in our unit, we're trying to kind of balance that and also bring environment to the heart of development. So today I just wanted to talk about a very new initiative that we have taken up, and I'm just going to pull up my screen. Just give me 1 second. I think it should be okay here. Yes, I think you can all see my screen, right? Yeah, is it okay? The screen's visible? Okay, I can't hear you.
Yeah, it's there.
Okay, great.
You can make full screen. Yeah.
Yes, cool, right. So, for the last few years, in fact, the last 3 years or so, I have been actually involved with a project with the National Mission for Clean Ganga, which is under the Ministry of Jal Shakti. The idea is to promulgate river-sensitive development, in our cities. And as we progressed into the into the whole project, one of the things we realized that river is a system, right? And I'm sure all of us know that. And there are various associated elements of the river. So the river can't be, if you want to manage a river, especially an urban river, it can't be managed in isolation. There are a lot of associated elements like wetlands, like water bodies, like drains. I think the previous presentation also kind of emphasized on that, right? So with that as a backdrop, what we have done is when it comes to rivers in India, we have a very nice way of kind of evaluating the health of rivers. Perhaps not as elaborate as some of the other countries do, but we still do have a system here, right? But when it comes to lakes and water bodies, the evaluation system is perhaps a little less robust, right? And this becomes really important, especially in context of what the government is now planning. Right? With the launch of the Amrit 2.20 mission that we've had, just recently, the focus is quite a bit on water bodies, right? Because in addition, of course, previously, all the urban missions related to water used to just look at water supply, supplying water or providing household tap connections. But now the narrative has changed. Now the narrative is more towards, improving water security. Becoming, getting our cities to climb up the water security ladder. Right. So it is in that context that we have come up with this diagnostic tool. It's called an urban water body diagnostic tool that we want to that we are that we have just developed in association with UNESCO, and the purpose of this tool is to help our city officials, city to make a very objective assessment of how the state of the water body is, a lake or a pond, and then which will then lead to what kind of actions need to be taken in order to revive and in order to sustain that water body. Right. So very quickly, just to take you through, like I said, the idea of this tool is to create a decision support system, for cities to manage their water bodies, which are so intrinsically related to rivers anyway. And this tool that we are developing would be valid for pretty much every city in India, including Varanasi and the other neighboring cities here. Right? So at the end of it, we thought that this tool should be able to help decision makers, in identifying and prioritizing actions that are required, to sustainably manage a water body. Right? So the idea was to come up with an indicator-based methodology, which would tell us what is the state, which would tell a city official what is the state of that water body, and for that, it's a very common criteria and a very popular criteria, the SMART criteria, that all of you must have, I'm sure, must have heard. So the indicators that we have chosen, of course, they conform to this criteria. But more importantly, we also wanted an indicator system or a tool that is fit for purpose. Right. The idea here is not to get into very fancy scientific techniques or elaborate analysis. Right. This is a tool that is to be used by city officials to make a very quick assessment of what the water body is, okay? And then that would lead to certain subsequent actions, right? So while the tool is grounded in science, of course, it's not necessarily scientifically robust. Elaborate. While it is robust, it is not necessarily elaborate, right? It doesn't have any fancy calculations and complicated or complex methodologies involved with it. Number two, like I said, it had to be rapid because this is something that a city needs to do. And a lot of cities, at Delhi, for example, I stay in Delhi, we have almost 1,009 water bodies, right? So you kind of want, you don't want the city officials just to be doing this throughout the year. So, we kind of needed a rapid tool that will help them to perform this whole assessment quickly. And of course, a very generic tool that can be applied to any city in India, right? So, so to any water body in any city in India. So here's, and of course there was a lot of, research, and we looked at different frameworks from across the world to see how other cities are looking, how other countries are managing their water bodies. But at the end, we thought this is what you see on your screen is the summary of this tool, which actually has 4 broad dimensions. We talk about physical characteristics, water quality, the quantity, and the water body management, how it is being managed. Now here it is important to kind of also distinguish between, we looked at some outcome-based indicators as well as process-based indicators, right? And this is important because sometimes with outcome-based indicators, there's not much can be done. If the DO is 0, that's it. What do you do with it, right? But with the process-based indicators, it actually tells you whether the processes are correct or not, and it makes it easier for that course correction to happen, right? So we decided let's to amalgamate the outcome and the process-based indicators into this, right? So just going through each indicator very quickly, one of the first indicators we looked at is the floating algal bloom or the visible eutrophication. Again, the way this would be evaluated, and I'm sure I perhaps don't need to go into what the impacts of this on water and what is the need for doing so, but more going into terms of the evaluation and the reference values that we have looked at. Again, this is something that city officials would look based on a visual examination, right? So what percentage of the water body is covered by floating algae? And based on that, there is a certain score that is given, to the, to that water body. So the range is between 1 and 5. So wherever possible, we've taken each number distinctly, 1, 2, 3, 4, 5. In some cases, it was not possible, so then we used a 3-tier range per se. The next one, which is pretty common in our cities, is the odor. Right, again, it's a binary indicator, whether there's an odor or whether there's not, right? A simple indicator just to kind of tell the presence of toxins or chemicals or even organic decay, in that water. For the water quality parameters, we debated quite a lot, and there were a number of parameters that were taken into the equation, but then finally we just settled on a couple. One of it is dissolved oxygen, which is again a very commonly used indicator in many places. Again, the idea is to test it. City officials can actually do this with just a DO meter, and then there are a set of reference values that are there, to give the score to that particular water body. The pH is a value that is being used in pretty much in pretty much almost all the assessments that we looked at worldwide, including Europe and North America. Right. Again, while it also indicates the level of toxicity in heavy metals, it kind of gives an indication of whether aquatic life can actually thrive or survive in water, because at the end of the day, that's the bottom line that we want. Again, a pH meter would be used to kind of check this with these reference values that you see on screen. Right. One of the challenges we had, was with the water body. We wanted to know whether there's enough water in the in the water body, and that would be a very good indicator to see how the water level has been changing over a period of time, right? The first thing that came to my mind, or came to our mind, was looking at water depth. But in larger water bodies, this is not that easy to measure, especially if it has to be done on a very rapid assessment. So instead, what we thought is we'll rely on satellite images to look actually at the spread, and at the circumference of the water body, and see what kind of a change has happened from the previous year, right? So using 1 year as a baseline, and then seeing, what is the change in the boundary of the water condition of the years, and then that can kind of tell us an indication whether the water body is shrinking or whether it is being encroached or whatever. Right. Now coming to the more process-based indicators, right? I think one of the common problems in the Indian water bodies is with encroachment, right? A lot of water bodies are being encroached. I gave you an example of Delhi.
The next speaker is our Commissioner Ghaziabad, who has some important engagement. So I'll request you to kindly, finish within 2-3 minutes.
Okay, sure. All right, so I think it'll be, maybe I'll just go to the last slide here. And just to let you know, okay, so this is how the whole equation looks like. In fact, this is the whole tool where we have the different indicators, the different dimensions of the diagnostic tool, which has the different indicators, and then it all culminates into an index from 1 to 5, right? And the idea is that if the water body is poorly managed, of course, it gets a score of 1, and then in ascending order, a well-managed water body would get a score of 5, right? So, I'd just like to stop here and say that this is, this is one of the ways that we are trying to help, our cities in India, to do a bit more objective assessments of the water bodies, and then which will help them to develop subsequent strategies for managing these water bodies. Thank you.
To Dr. Shinde, it's a wonderful work you have been doing, and definitely, we are closely working on decision support systems, DSS, and this Government of India Smart Cities mission. At IIT BHU also, we worked for what we say water for development planning, WDPI, and indexes. And then we have shown and worked that how our cities are existing on that scale. So it's a wonderful approach, and we hope that we will be working in close connectivity to develop it further to the benefit of the society. Thank you very much for a very nice scientific talk on that. Thank you. So nice. And now, next, we have with us a very dynamic. I mean, I have been in, yeah, I mean, learning about him, Sri Mahender Singh Tawar Sahab. He's an IAS officer and so much so interested, so much so actively taking part in the interest, related with river systems and water bodies restoration. So he is Municipal Commissioner Ghaziabad, and he has very successfully attempted to bring many, stakeholders together to bring health back to River Hindon. So let us welcome him and let us hear from him how he is trying to do and what is his message for us, River Varuna and Assi in our context. Uh, uh, Sir, I really, because we are going consequentially, so I know that you have high commitments, but still, you are welcome, and this is your time now. Please. Your mic is not, you are not audible, you are mute.
Thank you very much. First of all, I would like to uh, convey my sincere regards to everybody who is present in the second international conference
Yes,
on
still,
river health.
still, it is not very much audible to us.
Is it fine now? Am I audible?
To some extent better, but still not the best as you are.
How it is now?
Yeah.
Am I audible?
No, still the voice is not clear.
Audible, but it is very low. It is coming very low.
Then I am pushing my video off. I think that is the reason.
No, now it's fine.
No.
Is it good now?
Okay, okay, somewhat.
Okay, then I will do one thing. I will put my video off and I will just convey my message to everybody who is present in this
It's one and the same. Keep the video on.
You can keep your video on. Still it works.
It's
Okay. Okay.
okay.
So, first of all, I would like to convey my regards to everybody who is present in the second international conference on river health assessment to restoration. And I would also like to thank you, the two partners, IIT BHU and Water Resource Group, who is also closely working with us in Ghaziabad. And they are quite. So, if I start talking about Ghaziabad, then I think in 10-15 minutes I can share my experience in Ghaziabad. Ghaziabad is a place of 25 lakh people, and it is one of the industrial hub in Delhi NCR, consisting of around 100 wards. And as far as water demand is concerned, we have around a water demand of 375 MLD. And as far as water supply through all sources is concerned, then I think it is around 320 MLD. We are falling short of around 50 to 60 MLD water in Ghaziabad. And despite the fact that we have 8 STPs, and the capacity of these 8 STPs is around 480 MLD, still a lot of grey water and dirty water is flowing into the city. And I think we have to think on the ways uh, how we can improve our cities as far as drains are concerned. So in Ghaziabad we have focused on 3-4 things. First of all, we have worked upon the rejuvenation of 46 water bodies in Ghaziabad, and I will share the fact that more than 15 water bodies has been rejuvenated, and the 15 are in pipeline, and the rest of the bodies will be rejuvenated in next 3 months. I think by end of December, all 46 water bodies in Hyderabad will be rejuvenated. They will be the good source of water for more than 1 week. Apart from this, we have also introduced one TSTP, Tertiary Sewage Treatment Plant. Uh, Ghaziabad was the first municipal corporation which launched first green municipal bond in India, and we raised around 150 CR from bond market, and utilizing that money on HAM model, we are coming up with one TSTP, tertiary sewage plant. The idea behind this is that we are planning to give around 40 MLD water from one of our STP in Indrapuram to the industrial area called Sahibabad Industrial Area. That industrial area has around 1700 odd industries. So we are planning to give water, industrial grade water to them. I think this project it is under tendering process, and in the completion project, the completion time for this project will be around 2 years. So by end of 2023, this project will be on, and we will be providing 40 MLD water to these 1700 odd industries in Saibabad industrial area. So this is how we can utilize the burden of grey and untreated water through utilizing this way, and this is how we will reduce the pressure on the rivers, because Indian river and Yamuna river are also one of our rivers where our drains are going. So the larger idea is Ganga river, no doubt, but ultimately Indian river and Yamuna river both are also important. So this is how we are reducing pressure on these drains, and ultimately to the river Hindon and Yamuna, and ultimately again to the river Ganga. So, third thing we are doing, we have around 10 drains, and what we have introduced with the help of Water Resource Group 2030, unique idea. We are focusing on zero wastewater discharge wards in Ghaziabad, because what is happening, planning and implementing ideas on whole 100 wards, if we are taking city as a unit, it is becoming complex for everybody, for the implementers, for the policy makers, and for everybody. So what we are planning in Ghaziabad, let us divide our responsibilities and planning. So what we are doing in Ghaziabad is reducing planning and implementation scale to a single ward to reduce complexities in planning and implementation. So similarly, when we will be achieving this into wards, again our focus will be on zero waste water discharge industrial areas. So once we tap the drains or the grey or dirty water from wards and industrial areas, ultimately the pressure on river Hindon and river Yamuna will be very much less. And this is the ultimate objective of these kind of conferences. So this is how we are proceeding in Ghaziabad. So all the stakeholders who are interested, and all the people who wants to work closely with us, they are most welcome in Ghaziabad.
Sorry to interrupt you. Sir, we can hardly hear anything. So if you have any headphone or thing available with you,
I
please
think
use that, so it would be much easier for us to understand.
I think, ma'am, more or less I have completed my presentation also, but due to some network issues, I have joined from mobile only, and this is again some problem. So I think I can send my PPT later on.
Okay, sir.
Okay. Thank you very much, everybody.
Oh, thanks, Tawar Saab. Uh, this 2030 WRG group and this Municipal Commission, this office of Ghaziabad, they are working very closely on Hindon River, and IIT BHU has extended its support in its technical activities, although IIT Kanpur is already working and already they are in cooperation mode for that. So when we think of river Varuna, river Yamuna at Delhi, we cannot think of improving the health of Yamuna without taking care of Hindon. So we are focusing in our attention on Hindon River very much, and from our side as technical institution and scientific, understanding, we are all there with you. We will be working together to help you out in all situations, and let us form a part of this group as a team to achieve those targets. So thank you for sharing your your experiences and working for the purpose. Thank you very much for your presence and giving your precious time out of your very, I mean, tight schedule. Thank you so much.
We do not hear anything.
Yes, am I audible?
Yes, sir.
Yes, now. Yeah.
Oh, I just thanked Tawar Saab for his sharing the experiences, and we are already in working mode, and we are cooperating with Municipal Commissioner Ghaziabad for the health restoration of River Hindon. If we have to talk of a better health of River Yamuna in Delhi, we should work on River Hindon, and that is where the crux lies. So we are very much closely in cooperation with IIT Kanpur. IIT BHU is also joining, and we are working together to help the municipal commissioner of Ghaziabad so that we can work effectively on this River Hindon. And I thank Tawar Saab for joining our this discussion and sharing his experience. Thank you very much, sir. Next on our agenda is our discussion continuing in hydrogeology and environmental technology on river Varuna. So I see Professor Venkatesh Datta has joined us. He's and engineer V.K. Niranjan Sahab is also there, very much visible to you, sir. So welcome you, sir. You have a great team of experts with you, and I feel most of them have joined. Uh, in your team, your broad objective is to explore and examine what are the ways and means to ensure e-flow at Shashtri Ghat near Varanasi on River Varuna. And you are expert. I know on personal levels, Professor Datta, he himself is a well acclaimed authority, a person on this e-flow estimation on the river systems and how to plan for that. And V.K. Niranjan, he is the engineer-in-chief of our irrigation department. He is very much instrumental in water resources planning of this state. Due to some exigency of the situation, he couldn't come to Varanasi, although he was very much committal. He was saying that I will be reaching to Varanasi and taking part in this important conference from Varanasi itself. So, but in any way, Niranjan Saab, very much welcome. You are online, and and then Dr. Vidyarthi. Dr. Vidyarthi, are you there? Dr. A.K. Vidyarthi from Central Pollution Control
Sir, after 10 minutes, sir, joining, sir.
Okay. And Dr. Atya Kaple from NEERI. See, so those of you whose name are there in environmental technology, you can join over there. So now I hand over to you, Professor Datta and Niranjan Saab. Please take it.
Thank you so much, sir. I hope I am audible. Uh, am I audible?
Yes, sir. Audible.
Yes. Thank you so much for this August panel. I am very much happy to know that Engineer-in-Chief Sri V.K. Niranjanji is also here. He would be co-chairing this session. And this is a very important session on how to ensure a sustainable environmental flow into our river systems, especially on those rivers which are actually struggling for their survival, where there is not much subsistence water left to maintain the river processes, and not to mention all the cultural and the irrigation and other requirements. So in this session, we have 5 lectures from a very esteemed panel of speakers, and the objective is to explore the options which are available, or the options which could be designed to ensure environmental flow at Shashtri Ghat all through the year into the Varuna river. I would be also speaking, but I have a small presentation. I would be talking a little later. So now I give this floor to our co-chair, Sri V.K. Niranjan ji. He would just set the context briefly, and then we would start the presentation. So Sri Niranjan ji.
First of all, my tribute to Mahamana ji, this founder of this great university from where I graduated in 1985. My also pranam to all professors present at the IIT BHU campus and the office. So before beginning, Mr. Professor Datta is already there. He is really authority on this subject. But as far as the department's contribution and the department's role in how to ensure that efflow and how to ensure proper health of the river Varuna, the material that Professor Piegay Singh sir has provided, and all the material that we have at our disposal, both have been combined. And from the morning session, I have been joining it continuously, and I've enriched myself by the many inputs that especially Mr. Piegay has, and Director General Namami Ganga in the morning session. So as this session goes on, we will be at the last, I think we will be able to reach somewhere so that we can really restore the health of river Varuna. So there will be some, there are 5 speakers in this session, and I think let us start how to ensure that efflow, although it is a great subject. But only one thing that I would like to emphasize is that in the morning session, Mr. Piegay has, Mr. DG sir has emphasized the importance of the floodplain. I would like to extend that not only the importance of the floodplain, but the importance of the catchment of this whole Varuna river and Assi river. Now, catchment is very important because this is the area, or rather, catchment is something that provides and sustains that rivers. So what transformation the catchment has gone all through these years, and the river has really witnessed its near extinction of Assi, and Varuna is struggling for its survival. So that is very important. From that point of view, whatever the department has its disposal, I will be presenting when about the management of water in the rivers of Basin. With this, I think Professor Datta may give the opportunity to the first one, Professor P.Gilles. He will be sharing his views on hydro environment of Varuna sub-basin. So I think we can start from there. Your mic is off.
Sorry. Thank you so much for setting the context on not only the channel but the floodplain and the catchment. So to take the discussion forward, I would like to invite Professor R.K. Mal from ISCD BHU. He would be talking upon hydro-environmental perspective of Varuna sub-basin. So I invite Professor Mal here. I hope he's here.
He's not around. He's not visible.
R.K. Mal? He's not here.
He's not here.
So should we move to the second presentation? Okay, so second is mine, but I would like to talk at the end. Now I invite Dr. Baptiste from ENS Lyon. He will be talking on thermal imageries and groundwater surface water interactions, and how this could be applied to our own tributary here. So please, the floor is yours, and you have 15 minutes time.
Hi everyone, thank you very much. Can you see my screen?
Yes, it is visible.
Perfect. So, yes, my name is Baptiste Marteau. I'm a postdoc researcher here in Lyon in Professor Harvey Piegay's team. I'm really happy to be here today, and thank you very much for giving me the opportunity to share what we do here and perhaps discuss how things can be applied on your systems. I'm in the same position as Gilles Pinet just before. I'm not here to really talk about your own systems, which I don't really know, but just show some perspective on what we do and perhaps discuss how this can then be applied on your system. And what I do is work on thermal imagery from remote sensing, and to look at mostly groundwater, surface water exchanges, but not only. And I will show how this can extend then to tributaries. So yeah, this is basically, I'm a fluvial geomorphologist, but I'm interested in thermal processes in rivers from a spatial perspective, using thermal infrared imaging that we use from either drones or helicopters or ultralight trikes. And my purpose is to try to understand the role of fluvial geomorphology on driving temperature patterns in river systems, and then how these in turn has cascading effect on the biological compartment, with a particular interest on river rehabilitation. So I'm really happy to be able to show some of this work here today. So how will
excuse me, your slides are not visible. I'm not sure if others could see.
Okay.
Slides haven't come up. Your presentation hasn't come up.
So please share it again.
Sorry about that. I'll try again. Is it any better?
No,
we
not
don't see
yet.
it here. No, it's coming, but no, it's not there.
Screen is shared, but presentation hasn't come up.
Your screen is there. Maybe you can go to the presentation and check.
Yeah, it says I'm presenting, and can you see the slides moving?
No.
That's a pity. I can see things moving from my end.
So are you using Mac?
No, I'm using a Windows computer. Let me try again.
Yeah.
Sorry about that. What about now?
It says you're presenting, but we couldn't see your slides coming on the screen. Maybe after sharing, you have to go to that particular, slide.
Yeah. Well, it works fine on my screen, so I'm really surprised. Let me try with another browser, perhaps.
Coming up.
Yes, now it's
Coming up.
coming up, so you could. So meanwhile, those who have nominated as speaker in the other parallel session, they should join the separate group. The link is given in the chat box.
Okay, can you hear and see me?
Oh, yeah.
Yes, now it's there. So
Okay.
you go to
Yeah,
the
come up. It has come
you
up.
can go to the full screen.
Yes.
Yeah.
Yes, Dr. Baptiste.
Thank you very
Yes,
much,
come
and
up.
sorry about the technical issues. I was just saying that the structure of my presentation is going to be rather simple. I'm just going to show what is thermal infrared and how we use it, how it works. Expand a little bit on the data acquisition and post-processing workflow, just from technical perspectives, and then see how we can use this to look at tributaries and how they play a mediator role on mainstream processes. Highlight also their role as a major source of thermal refuges, and then talk a little bit about rehabilitation of thermal processes, as this is one key aspect of the things you wanted to talk about today. So the basic principles of airborne thermal infrared is quite simple. It's all based on the principle that every object or every body that has a given temperature is emitting radiations. And these radiations, we are able to measure them using some very specific sensors. In this case, we use what we call a thermal camera. And with this thermal camera, we are able to measure radiations within a very specific range. And in this case, it's a small part of the infrared band, which we call the thermal infrared band, and very more specifically, the long wave of the band. And with that, and doing some calculations based on thermodynamics, we can actually infer the temperature of a body, or in this case, of a river, from the distance, remotely, without having to put a probe in the river. In reality, it's a little bit more complicated because of the properties of the water, which are quite specific. We always need to have thermometers in the river to be able to compare what we have on the images and what is the true temperature of the river, just for the sake of calibration and validation. But the principle is to then apply this to tens of kilometers of rivers. And how we do this, basically we just install our two sensors on a flying machine. I usually use ultralight trikes, like what you see on the picture here, but it works the same with a helicopter. And you can also use drones, although we can discuss it further if you want, but cameras on drones still have some limitations today. And with these two sensors on board, I'm sorry, the slide is in French, but it's quite obvious from the images. We can get two types of data. We have thermal images and also just classic RGB photographs. The process then is to calibrate or validate the thermal images based on the thermometers that we place in the water. And also we use the classic RGB photograph to create an orthophoto of high resolution from which we can extract all sort of information. Resolution is usually about 5 to 10 centimeters for the RGB photos and 25 to 40 centimeters for the thermal images, which is quite high resolution. And from the RGB photographs, we can also look at some geomorphic properties of the river, and depending on the width which we acquire, we can also look at the entire floodplain, such as connectivity patterns, the presence of wear or vegetation, where the tributaries are located, and so on. And with these two projects combined, we can then get two types of data. We get a longitudinal profile of temperature from upstream to downstream, which is with an example you have here on the top. And we also get a 2D image of the thermal, the temperature of the surface, which can then be used to extract and detect what we call thermal anomalies, which are either spots of cold water or spots of hot water that are released in the river. Usually, when we work in the summer, at least in our European context, summer is usually much warmer than winter. So we have a warm river within which groundwater interactions are visible through cold water patches that are released in the river. But the opposite is also doable. If we work in the winter, then we have a cold water body within which groundwater upwelling will be visible as warm spots. So both scenarios are possible. The idea is really to work at the time where the temperature contrast will be the most important, either at the warmest time of the summer or the coldest time of the winter. Different types of vectors and sensors are available, like I was saying before. Some sensors are what we call vector specific. So they are designed to be mounted on very specific vectors. Here are just some examples. In the US, they use very often an airplane with a very specific and quite large sensor, so they can fly really high and then still get high resolution images. What we tend to use in Europe is more either helicopters or utilized trikes, like I was showing before. And we're also seeing development of drones with miniature thermal cameras. But these cameras are still in the early stage of development, and we still see technical difficulties in acquiring good quality data. So I would suggest using drones as a last resort or on very specific objectives. But you can also use any type of thermal camera which has an industrial use and then apply it to a non-specific vector. And this is what we do with the ultralight trike. The camera we use is not designed to be used airborne, but we have created a system that allows it to be fixed and secured on our ultralight trike, and then we can fly it. Some colleagues in Canada have done the same on helicopters. This is the bottom photographs where they've used a pod on the side of the helicopter, which they designed to fix a commercial thermal camera inside. So many scenarios possible, and it's all adjustable to the system that you want to survey, whether you want to have images on a very small or a very large river, the distance you want to cover, the quality of the images you are requesting, the resolution, and so on. So this is how it basically works. And as I was saying before, you can do the same either in the winter or in the summer. In the summer, you will have cold water patches visible within a warm river, and in the winter is the opposite. You will have warm water patches visible within a cold river. The processing of the images is one of the development that I did during my postdoc here in Lyon. We use SFM photogrammetry, which is a series of algorithms all combined within the software that allows several images to be matched together to create a mosaic, but also to build a 3D model of the object that is photographed. So by combining classic RGB and thermal images, we are able to create two sort of orthophotos, a classic one and a thermal one. And then the purpose is to simplify. With SFM photogrammetry, you can accelerate the processes of aligning the images and also georeferencing them within a coordinate system, and then you make sure that the two orthophotos are matching and overlapping properly, and then you can extract all sort of information from that, from all sort of geographical information. And then the two main projects that I was mentioning before are the long profile of temperature from upstream to downstream, but also detection of thermal anomalies, and then you also have an idea of where they are located in the river channel. So coming back to the topic of the talk today, which is about tributaries. We know that, like I say, my background at the origin is more, I'm a fluvial geomorphologist, and we know from a geomorphic perspective that tributaries are really important controls of physical heterogeneity in rivers, and also the biological diversity that goes with it. And they are also really important sources of coarse material. If we have a tributary that is downstream a dam, it is usually the best way to reinstate an active coarse sediment dynamic. But they can also be really significant sources of fine sediment, with sometimes issues that come with it, related also to the hydrology, and they are drivers of connectivity at the catchment scale. One of the best examples is fish migration, where a lot of fish that live in the sea and like to breed in rivers, they need tributaries to go and breed. But then, what does that mean in terms of temperature and in terms of thermal processes? Here are just some illustration of the things that we can see from the air. This illustration is taken on the Lyon River here in France, where a tributary comes in the Lyon with a 5 degrees difference, which is quite important. It is significant. And what we can see on the images, I don't know if you see as well on your screen as on mine, but is that the mixing, because of the temperature difference, the mixing takes a long time to do, which gives us a very diverse and a very wide gradient of thermal habitats. And what the subthermal infrared imaging allows us to do is to actually see the invisible. We are able to map on the map where are the different thermal habitats, and then we can relate that to either pollution or the presence of specific organisms. And one of the key organisms that we like to look at in France when it comes to temperature is usually fish. We have a lot of fish with very specific thermal preferendum, which can live in some of these tributaries where the river is cool, but not necessarily in the main stem if the temperature is too high. Here is another example of that same river when it then flows into the next river, which is the Hérault River. Again, the river was cooled down by really important tributary inflows of cold water, and then it is in turn also creating a high diversity of thermal habitat at the next confluence. So every tributary confluence is on this particular basin, every tributary confluence is actually providing a high diversity of thermal habitat, highlighting the key role of maintaining tributaries in a good state and keeping an eye on the thermal regime of these tributaries, because it is providing very valuable habitat in the main stem. On very large river, this is an example on the Rhône basin. Tributaries also have a role in mitigating human alterations. Here, for instance, all the blue arrows show inflow of tributaries, which usually have a cooling effect on the longitudinal patterns, on the longitudinal profile of temperature. A tributary inflow usually decreases the temperature of the Rhône. But then all the red arrows are nuclear power plant release of hot water. And so what we see is in a system that is really large and really altered by human and anthropogenic pressures, then these tributaries have a role in sort of mitigating or mediating the human alterations, such as nuclear power plants. Here's just one illustration of what we see from the thermal images. We have a nuclear power plant release, water is almost 4 degrees warmer than the Rhone River itself. And we can clearly see the plume and how it then degrades and mixes within the Rhone. And I'm not showing it here, but when we look at the long profile, we can see that the mixing actually takes more than 2 kilometers to actually be active. So this is one of the key things that we can see from these images, and assess the spatial extent of thermal pollution in this case from nuclear power plants. The same can be applied to hydropower plants, but then the other way around. Usually, if you have a dam and a bottom release system, then the water that is released by a hydropower plant will be cooler than the actual temperature of the river. Whether this is still mentioned as thermal pollution, it is a debate, but it creates a gradient of temperature that is and a contrast that is clearly visible on these images. Here, for instance, we have up to 1 degree difference between the canal that is coming from the hydropower plant and the Rhone River itself.
Can you conclude within 2 minutes, because we have other speakers as well?
Okay, yeah, well, we can discuss it further later on anyway. Just to conclude that tributaries are also major sources of thermal refuges. These are thermal images on the left, on the right, showing a plume of cold water, and we can observe that the fish are actually always staying within this plume in a particular area to survive hot spells in rivers. And in this example, some colleagues in Canada have looked at how fish were actually using cold tributaries, and they were migrating in cold tributaries when the water of the temperature was too high, just as a protection, as a refuge. So this is just to highlight the importance of tributaries in providing thermal refuges. Here is another example where they looked at the distribution of cold water refuges related to the presence and absence of tributaries, and they found an overrepresentation, meaning a higher quantity and density of thermal refuges in the vicinity of tributary confluences. And I was just going to finish with this few slides on a river rehabilitation initiative that has taken place in France on the Braided River, where the purpose was to restore braided channels and enlarge the river, which was in size after years of gravel mining. It was a huge amount of work, a lot of people involved, a lot of sediment that was taken back into the river. And what we've seen basically is comparing the rehabilitated site with a natural sort of control site, is that the thermal processes were not completely restored with the restoration of the river. Maybe because more time is needed and more powerful flows are needed to reshape the newly rehabilitated site to look more like the natural one, but also this gives us an idea of the limitations of only acting on forms when we restore rivers, and the limited consequences this may have on actual processes. And assessing these thermal processes can be an important way to actually get a better sense of what rehabilitation can achieve. And so in conclusion, I was just going to say that thermal infrared imaging allows us to have a detailed diagnosis of a river thermal regime, and that has showed the fact that tributaries are key sources of thermal refuges for fish, but also key in mitigating some of the human alterations. And I would like to finish with this on river rehabilitation. It sometimes gives us contrasting results when we look at processes and not just forms. And so my key message would be that protecting tributaries and trying to work on conservation is perhaps what should be thought first before moving on to restoration and rehabilitation. Thank you very much.
Thank you so much on talking on how the thermal stratification could affect the freshwater ecosystem. We have this kind of phenomena in the tropical river systems which are groundwater fed. In fact, I can give you some perspective. When I was a child, I used to take bath in a local river, and the water used to be warm in the morning because I could see the groundwater upwelling from the bottom of the river as huge base flow. So you could even in the winter take a dip in the river, and it's a shallow groundwater contributing to the river flow. So it is very important to know the exact certification. So moving forward, thank you so much for giving your time here.
Thank you.
So we would take the debate further forward with our next speaker, Professor Shishir Gaur from IIT BHU, Civil Engineering Department. He would be again talking on how the Varuna River is interacting with the aquifers, the groundwater systems. So Professor Shishir Gaur, he's here. Do we have Shishir Gaur here? Do we have Professor Shishir Gaur here? If he's not here, then we will move to the next speaker.
Professor Shishir Gaur is not here. We can go ahead with him.
So next is Sri Niranjan ji. So I would request him to speak now. He is our engineer in chief, and he is the overall in charge of the entire water resource department of Uttar Pradesh. And I should tell you, the Uttar Pradesh could have been the 5th largest country in the world. So he's like looking after water resources of a big country, you know, just like population size of Brazil. And we have huge canal network, almost like 74,000 kilometers of canal network, 8 major river basins, and it is a big challenge to look after the entire water resource regime and the connected landscape. So I request Sri V.K. Niranjan ji to speak for about 10 to 15 minutes, and then we'll have the floor. Thank you.
Thank you, Mr. Datta. First of all, I really feel very enlightened to be among this group. So, as we all know, Varuna River, it takes up from Mau Aima, that is in district Pratapgarh. And as per the records of the department, the whole length is 212 kilometers of this Varuna River, from Pratapgarh to its confluence with River Ganga at Varanasi. But in the morning session, it was also discussed that this is also a matter of debate. Where is the origin of this river? And this is really, supported by the facts also, that when we put it on GIS platform, the length of this river came out to be 169 kilometers. So that means 43 kilometers of the upper reaches is already lost. Now it takes off, the river is visible only from district Prayagraj, that is Allahabad. So 43 kilometers is lost, and Mr. Piegay has just told in the morning session, it discussed very finely, that you have to start cleaning from the top stair. So as from that principle, we have already lost many top stairs. 43 kilometers of the top of this high reach of this river Varuna is already lost. So this is also a cause of concern for all of us, how to restore this river from its original origin. And there are 5 major districts from where it passes: Pratapgarh, Allahabad, Jaunpur, Bhadoi, and Varanasi. Now, from all these districts, it joins Ganga at near Adi Kesav Ghat. We have as department, we have got one gauge site at Kalika Dham on river Varuna, from we have been observing the discharges. Now, from the discharges, it is very evident that the highest discharge that has been observed from the year to year, it has decreased, but it has not decreased very substantially. That means the river still has the potential to be revived, and the river is still very much alive. Only thing is but one significant result that comes to our light is that during summer season there is absolutely no flow. There is zero flow even at Kalkadham, which is just 59 kilometers from this confluence to the river Ganga at Varanasi. So base flow is almost nil, and whatever flow, it has become a typical monsoon or seasonal river, where there is flow only during the monsoon season, and during even the monsoon season there is a large variation in the highest discharges that has been observed. From 270 cumex, as has been observed in the year 2003, it was the highest, and the lowest was in the year 2020, that is 60 cumex. This year also, we have around 152 cumex has been recorded as the highest discharge. So there is a variation, but there is not a very large variation. But one thing that comes to significance, if we study the catchment of this area, now one of these variations are consistent with the rainfall over the catchment. Whenever there is a good rainfall, there is a good discharge also. That means the relationship between the rainfall and the surface runoff is very much intact. Otherwise, in some of the districts, the department has found that despite rainfall, there is no runoff. So that means something very drastically wrong has happened with the catchment, that even with the rainfall, the surface runoff is not generated. But here, that relationship is intact. But going into the sub-basin, suppose Varuna is a river, then we have two major tributaries of river Varuna. One is Basui and one is Morva. Now, state of Basui river is very important for the state of health of this river Varuna. Basui river wholly falls in the Jaunpur area, in the district Jaunpur. So whenever there is a drop in rainfall in district Jaunpur, there is a very drastic reduction in the discharge in the river Varuna, even during monsoon season. Even if there is a good rainfall, a better rainfall overall on the catchment, but if there is less rainfall in district Jaunpur, then we find that there is a lesser discharge in river Varuna. That means Jaunpur plays a very important role, because Basui river is the major tributary. So as in the morning session, these tributaries are very important. These small drains are very important. This Basui river may have many drains. That has to be studied very well. What are the small nala that we call, which may be contributing to Basui river, and Basui river in turn contributes to the river Varuna. Now these nalas are very small, seasonal. They flow only during season. One of the things that has come to the notice and is very rampant nowadays is that these nalas has been encroached in a very large manner. So all these drains and nalas has to be restored to the Basui. It has to be studied in detail how many drains are contributing to the river Basui. Then there is some inappropriate developments also that is going on in the district, especially in the morning session when Commissioner Manrega was speaking. Although excavation of the river section is all right, but it has been observed very extensively. And in one of the findings, when I was chief engineer in Saryu project, I studied the state of river Tedhi and Old Sarju in district Bahraich and Gonda. where I found some inappropriate type of developments have contributed to the extinction of river Tedi. And for example, even the department has constructed some marginal embankments where the river has been cut into two parts. And therefore, this old Sarju is almost extinct from district Bareilly to its confluence with river Ghagra. So we have to study how Bisui river is there any adverse impact of development on river Basui in the form of construction of check dams. Whenever there is a construction of check dams, it is found that after a decade, the section of the river is lost. The base flow, there is a aggradation of the river. The bed rises upstream of these check dams, and if there is a series of check dams, almost the river becomes extinct. Therefore, we have to study how many numbers are of the check dams have been constructed by the Department of Minor Irrigation or through Manrega, and what is the impact of these check dams on the health of the river Basui in district Jaunpur and in district Bhadoi, where Morwa river contributes to the river Varuna. Because I found that in Bundelkhand, one Urmil dam was constructed of a very large capacity from the Bundelkhand point of view, around 110 MCM. But it is almost, even after the end of the monsoon season, this whole dam remains empty because a series of check dams have been constructed by Madhya Pradesh on river Urmil. And therefore, there is absolutely no contribution from the river to the dam. Same thing has happened with the Modha Dam, where there is a number of check dams constructed on river Birma, and therefore there is no contribution from there. From that point of view, whenever a detailed study, as I have been told that it will be a group has been constituted to study this river Varuna. So my real suggestion is that group as well as the department will also study, as it has been brought to the knowledge by Professor P.K. Singh. I've rather instructed the field officers of district Jaunpur and district Bhadoi to study the river Morwa and river Basui. How many check dams have been constructed on that? What is the impact of the check dams on the state of this river? So we have to also study how is there any such type of so-called development. Third is there are so many roads have been constructed as a developmental activity, but enough cross drainage work, the culverts have not been constructed, and therefore this whole drainage is blocked. The relationship between this rainfall and the surface runoff is not a very healthy relationship. Even when there is rain, the corresponding surface runoff is not generated. Therefore, in district Jaunpur and district Bhadoi, where there is a major contribution from these two districts, in the basin of river Varuna, has to be studied in detail, and if there is any such type of blockages, it will have to be brought to the notice and remedies has to be taken. Now, studying the catchment area of this whole Varuna, Prayagraj, Jaunpur, Varanasi, Bhadoi. Now, from the GIS input, the catchment is 5,886 square kilometer. Out of this, the major portion is 42% lies in district Jaunpur, where there is river Basui. So from catchment point of view, also it is very evident that the Basui impacts river Varuna in a very major way. And the secondly, it is 17% is Bhadoi. So river Morwa also contributes to the river Varuna from district Bhadoi. So studying all these factors, it is very evident that the small rivers, so-called small rivers, their health is very important for the health of river Varuna. As far as we have also got one Gyanpur pump canal that is constructed in Prayagraj in the Handia district, from where one of the canal system takes off. As Professor P.K. Singh has told that some provision for the water for the revival of Varuna is from Gyanpur pump canal. So from the department point of view, my request is actually this is something rivers. The canal takes off from rivers rather than a canal feeds any river. So the source of the canal is river. The source of the river can't be a canal. But anyway, when the river is in a very unhealthy state, so as a very temporary measure, until the river is restored properly, we can think of providing some additional water from Gyanpur pump canal. There are 9 pumps of 150 cusecs in river in Gyanpur pump canal. From there is a one escape, 3.5 kilometers. It joins around upstream of Varanasi, where 150 cusecs of money of this water can be given. As per when I studied this project, when Professor P.K. Singh told me, then it's really a fact that some provision has been made in the project for providing some additional water to feed the river Varuna. So I had a very detailed discussion with the Chief Engineer Son Varanasi, how we can provide some water to river Varuna, especially when the time when there is a very acute shortage of oxygen or the pollution level is very high. We can provide some water to river Varuna. As I have been told by the concerned Chief Engineer at Varanasi, that they do provide the water, but it is not at a very consistent or continuous level. So whatever preparation has to be done, the department will definitely do it. And we'll see that 150 cusecs of water is continuously provided to river Varuna from Gyanpur pump canal. But that is simply like providing the oxygen to a patient and can't be a solution. The solution has to restore the health of this whole ecosystem of river Varuna, where its tributaries, Basuhi and Morwa has to be looked in very detail, and all these seasonal drains that contribute to Basuhi and Morwa, they have to be looked into detail. They have to be restored, and only then we can start thinking of restoring the health of the river Varuna. As far as Assi is concerned, that is tomorrow. My another colleague, Mr. Muzdavedi, will participate and talk about it and how to revive that river. With this, I thank Mr. Professor Singh and Professor Datta to give me this opportunity to provide a perspective from the departmental point of view. And as Professor Datta has just told, that Uttar Pradesh is really a very large state. This department is just like managing the canal system and the water resources of a nation. We have one of the oldest departments, 70,000 kilometers of canals, 8 river basins, rather 12 major rivers, and around 250 small rivers. We have some gas sites around on the river, on some 70 small rivers, and in all the 12 major rivers, where we measure these discharges all around the year. And then we also we are in contact with the groundwater body, with the authorities also, where we measure the drop in the drop or rise in the groundwater. And with that also, groundwater is a major change that has occurred, especially in the basin of river Varuna. there is, on the average, there is a more than 5 meters of drop in the water table of district Jaunpur. That is a very so critical to the river Varuna. So this drop in the water table has also contributed to the absolutely zero base flow of river Varuna during summer season. Therefore, this whole revival of this river is really a very multitask, where the Department of Groundwater, Department of Minor Irrigation, and administration all have to be involved there. And one proposal from the department side is also going on. We can the establishment of these basin authorities in all the 8 river major basins. There is a proposal to establish basin authorities where there will be responsible persons from all the departments, administration, groundwater, irrigation, flood, and minor irrigation, all departments there. And unless that authority is established and given some administrative and executory power, this whole river basin and the revival of the basin will remain incomplete. But till then, this initiative of IIT BHU is really a very welcome step, and the department looks forward how we can contribute to the revival of river Varuna in particular, and all these small rivers in general, which are so important for the big rivers, because the tributaries, the tributaries are very important now. And the emphasis is now being felt that with giving emphasis to the big rivers also, it is also important to give equal importance to the tributaries of the small rivers, and therefore we will be contributing to that. With this, I think the revival of this river Varuna takes off, and department will feel really entitled and very enthusiastic to contribute from our side whatever is possible. Thank you very much.
Thank you, sir, for setting the context in a very constructive way. You have highlighted 5 major points which I would talk upon after my lecture is there. So basically on the integrity of the catchment, floodplain, and also on the restoration of water bodies that feed into the Varuna river itself. So some of these points I have covered in my lecture. So I would try to reflect upon those points. So let me share my slide here.
Datta sir, am I audible?
Yes, you are audible.
I just want to have a conversation with Mr. Niranjan.
Right.
Sir, I heard all your things and every proposal, what you are talking about. You are talking about tributaries and sub-tributaries and the entire sub-basins of the river Ganga. So here on behalf of NMCG, I am Nidhi Dwivedi and working in the capacity of project officer NMCG. So we are at NMCG also thinking of rejuvenating these smaller rivers to maintain the e-flow in the main stem of the river Ganga. So of course, Varuna being part of Varanasi is one of the major crux of, everybody's eye is on this river and everybody is talking about it. So instead if on this platform, taking benefit of this platform, I would like to submit to you that if possible, instead of asking everybody to come on the same board, at least one should start. थोड़ा थोड़ा होके सब मिल जाएंगे. जैसे आप एक HOD है इरिगेशन डिपार्टमेंट की, यू टेक लॉट ऑफ एफर्ट्स, आप चेक डैम्स की बात कर रहे हैं, बट अलोन चेक डैम्स आर नॉट ओनली रिस्पॉन्सिबल फॉर लेसर फ्लो in these smaller tributaries or small rivers. So there are various other factors also working, like encroachment, like हमने हमारे जो ponds हैं वो सब encroach upon हो चुके हैं, जो उसके source of water है वो encroach upon. तो उन सब चीजों को अगर हम किसी proposal में identify कर पाए कि भाई इनका ये source है, यहाँ से इसमें पानी आ सकता है, एटलीस्ट लीन फ्लो में तो वहाँ पे लीन पीरियड में तो वहाँ पर फ्लो आता ही होगा कहीं ना कहीं इन्हीं सभी सब स्टोरेज एरिया से। तो आई एम श्योर कि कुछ ना कुछ ऐसे एरियाज या ऐसे पॉन्ड्स या स्मॉल वेटलैंड कैचमेंट कुछ भी ऐसा होगा उन एरियाज में जो कभी ना कभी उस पर्टिकुलर ट्रिब्यूटरी को, वरुणा की ट्रिब्यूटरी को इन जौनपुर अपना फीड देता होगा, अपना फ्लो देता होगा। तो हमें उन चीजों को थोड़ा सा पुराने मैप्स निकाल करके आइडेंटिफाई करके उन्हें कुछ चीजों को सामने लेकर के आना पड़ेगा। फिर पर्पजली हम उस चीज का प्रपोजल एक बार हम कंसिडर कर सकते हैं कि भाई हम उसमें आगे कैसे बढ़ सकते हैं। पर जब तक कि थोड़ी सी भी चीजों, और ये नहीं कि सब कुछ एक साथ करना है, थोड़ा भी शुरू करेंगे तो शायद आगे का रास्ता अपने आप दिखने लगेगा। तो अगर हम एक पार्ट जौनपुर कवर कर रहे हैं, या आपने मोहाइमा की बात करी है प्रयागराज के पास में, समहाउ अगर आपको 2-3 ऐसे क्रक्स पॉइंट्स दिख रहे हैं, हम कहीं से तो शुरू करें। जस्ट मेरा आपसे यही सबमिशन है कि इसके लिए अगर आप हमसे फर्दर इस सब चीजों पे डिस्कशंस करेंगे तो हम लोग इन सब चीजों को थोड़ा सा और आगे ले जा सकते हैं। सो दैट्स व्हाट माय ओनली सबमिशन इज सर।
Your suggestion is really welcome और इसको लिया जाएगा। बट शुरुआत करने के लिए अभी शुरुआत हो ही रही है। लेट्स स्टार्ट फ्रॉम वरुणा एंड अपार्ट फ्रॉम प्रोवाइडिंग adding 150 cusecs of water from Gyanpur from canal, I will be very much taking the Basui river as a departmental task, how to restore and what are the different drains, because we have got some departmental drains in every division that are working in different districts. So district Jaunpur, all the divisions working in district Jaunpur, I will make sure that all the departmental drains are restored in that which drain into river Basui. तो इसी तरह एक बूंद से घड़ा भरेगा और हम निश्चित रूप से आई एम वेरी श्योर कि एक बूंद करके हम जो है वरुणा को भी रिवाइव करेंगे और हम सबका ये परम कर्तव्य होगा। और अत्यंत ही प्रसन्नता की बात होगी कि वरुणा रिवर अपनी पुरानी उस स्थिति को प्राप्त कर सके। थैंक यू।
ओके, थैंक यू सो मच। आई थिंक मैं भी कोई कोशिश करूंगा आपने जो ये सवाल उठाया है उसको कवर करने का। तो आप मुझे बताइए कि मेरा प्रेजेंटेशन दिख रहा है आपको? कैन यू सी माय स्लाइड्स?
यस यस, विजुअल।
यस, सो let us talk on the environmental flow assessment and environmental flow releases rather, क्योंकि assessments तो बहुत कर लिया, अब हम लोग release की बात करते हैं। सबसे पहले I want to talk that this river is majorly fed from the groundwater, and Varuna being the foremost controlling drainage system of Varanasi, it is very important to keep the catchment decongested, to keep the channel fragmented, right? Fragmentation of the channel जो हो गया है, जो फ्रेगमेंटेशन हो रहा है, चैनल टूटता जा रहा है, जिसके बारे में अभी निरंजन जी ने बताया। Secondly, the base flow index of this river is very high. Base flow index tells you how much water is coming from the groundwater. 75% to 80% of the water into Varuna river is coming from the groundwater. आप सोचिए, and इसका जो source stream है, there are large ponds and tals, paleo channels, oxbow lakes, retention ponds, और खासकर दो बड़े तालाब जो उमरान और दैन है, जो अपर कैचमेंट में है, बसुही और जो मोरवा रिवर की बात चल रही थी। तो इसके बारे में भी हम बात करेंगे कि जब तक हम बेस फ्लो इंडेक्स को जो नीचे जा रहा है, मेरी आवाज पहुंच रही है ना, क्योंकि मैं देख नहीं पा रहा हूँ।
Yes, yes, it is audible.
Okay, so let me come to my next slide. Now, if you examine the land use land cover change of the Varuna catchment during the last 42 years, I did a small exercise and I was baffled to see that there is a decrease in agricultural land by 48% in the lower part of the basin. And it has been a lot of buildings and road networks and so many constructions are coming up in the catchment of the Varuna river, and the groundwater table is going down rapidly. Right now, Varuna in 99, you saw the data. Varuna was it was a gaining stream. Groundwater used to contribute, like the previous speaker talked about the groundwater upwelling I have seen it actually in the Gomti river systems. Many tributaries I have seen near Naimisharanya and Hardoi. If you go early morning, you will see a lot of big bubbles coming, rising from the base of the river, and they are nothing but the groundwater. And if you take bath in the winter, you'll also see, you'll find the river is warm. So basically the groundwater is contributing to the surface flow. Now what is happening today is the Varuna river has become a losing stream. The groundwater table has gone down very significantly, like in Jaunpur, as Niranjanji was saying, that decline of 5 meter at some places in a few time span. So there's a drying tendency here. Uh, uh, you see this channel, you could hardly find any water these days, except in the monsoon when the river is flushing. So if you examine the discharge data, some reference was given by the previous speaker that this is the 2003 discharge. If you see, still the river was flowing with life. In January, you have the average discharge of about 14 cubic, right? But in September, when the river is flushing with a flushing flow, there is a 270 cubics of discharge. So out of these 12 months, you have only few months when the rivers are struggling, like January, February, November, December, and May. Rest of the months, the river was flowing. This was till 2003, right? Now, coming back to the E-flows, what are the measuring conditions? First of all, we must understand the variability in space and time, the temporal and spatial variability, and the long-term studies over entire catchment. As it was pointed out that check dams are actually destroying the river systems. But some of the smaller tributaries and the smaller order streams are surviving on check dams, in fact. So check dams are good for lower order streams, the first order streams and second order streams, but not the master drains. If you destroy the master drains, the other order of streams would be destroyed. Secondly, we have to distinguish between the natural and anthropogenic effects. Now, what is happening with the varying human influence? Every catchment components are getting disturbed, including the rainfall runoff system, the dynamics of what Niranjanji was saying, that rainfall is not directly resulting into that runoff, which was very typical in a typical hydrograph. So what are the questions which could guide e-flows for particularly for Varuna river system? First of all, how to link between the flow and the ecosystem, that is the flow defines the ecosystem and flow is the master variable. There are flow dependent ecosystems. So how do you establish? So right now we are not talking on those terms because currently अभी हमारा concern है कि पहले नदी को थोड़ा सा revive किया जाए, then we talk about the flow ecology relations. Then there's a link between water quality dilutions, the nutrient loading, and how much wastewater is coming to the river stream and how much water we need fresh infuse of fresh water. And thirdly, can restoring flow restore an ecosystem? Very big question mark, because environmental flows may not restore the ecosystem in a shorter span of time, because ecosystem restoration takes years and years. The second aspect is the variability of flow. We try to mimic the natural flow regime of a tropical river, which is very characteristic of even smaller river systems like Varuna and Vasuhi and Saryu, and he was giving the example of the tributary of Saryu, Tedi River. Tedi River originates from a tal, and that tal has been fragmented by the National Highway project. So even the source is being disturbed, and that disturbs the entire variability of the flows. You have only the subsistence flow, but the river needs overbank flow at least for few days. 14 days of flushing flow is required to flush out the sediments. Similarly, there are high flood pulses, right? So these variety of flows are even characteristics of the big tropical river systems like Ganga river, where you have the base flow in the dry season, and then there is a base flow in the wet season also. And this dry and wet season connectivity keeps your entire hydrological system in order. Now what is happening? We talk about E-flows. environmental flows. I have worked on e-flows, but now I realize that we need to go beyond this, our over emphasis or our rather, we are overly emphasizing on the environmental flows. But what are the problems? I have calculated the e-flows using all the methods available, SMACTIN and TESTMAN, building block methodology, ILOHA, drift. There are so many methods, but all these methods are Western methods. We need separate ecological flow methodologies for rivers like Varuna, where the source is only groundwater. 80% source is the groundwater. And unless until groundwater meets the surface water, you cannot revive the river without with simply water releases from a canal, right? Now, reference condition is very difficult to establish natural flow. I have the data of 99 or 2003, which I'm trying to develop, but I have the cross-sectional data, which I'll show you later on. Knowledge base is very limited. Minimum environmental flow generally implies maximum abstraction. ये हो रहा है खासकर बड़े रिवर्स में कि हम एक बार बोल देते कि ये हमारा मिनिमम इन्वायरमेंटल फ्लो है, तो रिवर तो इससे ज्यादा फ्लो कर रही, तो हम निकाल सकते हैं. ये भी आजकल हो रहा है कि एक मिनिमम वर्ड इसमें ऐड करके we use maximum abstraction. So we have to avoid that. And there is no single correct e-flow regime for a river. The right answer will depend upon what we want from a river. हम वरुणा से चाहते क्या है? हम वरुणा को जिंदा रखना चाहते हैं. वरुणा को एंशिएंट लिविंग रिवर सिस्टम्स जो कि आज भी जिंदा है, जिसमें लिविंग एंटिटीज है, लिविंग सिस्टम्स है, या एक इसको वरुणा नाला जैसे अस्सी नाला हमने बनाया. तो इन्वायरमेंटल फ्लोज जो है, इट इज अ बैलेंस बिटवीन ह्यूमन नीड्स एंड इकोलॉजिकल हेल्थ या रिवर हेल्थ. अभी रिवर हेल्थ को अगर हम यहाँ पे करेंगे, ह्यूमन नीड्स अगर इसका पलड़ा भारी हुआ, ये पलड़ा क्या होगा, ऊपर उठ जाएगा, ये हल्का हो जाएगा. सो वी हैव टू वर्क ऑन ऑल्सो अदर देन द कैचमेंट्स. हम नदी की बात तो करते हैं, लेकिन नदी के साथ रहने वाले जो कैचमेंट्स के लोग हैं, जो फ्लड प्लेन्स के लोग हैं, जो एंटायर सस्टेनेबिलिटी जो लाइफ साइकिल है उसकी बात नहीं करते. खैर ये तो डिस्कनेक्टेड बात हो गई, लेकिन मैं फिर दोबारा इस पे आता हूँ कि हमने वरुणा का कैसे ई फ्लोज निकालने की कोशिश करी. सबसे पहले I want to talk on that. We will consider only these three aspects for the time being. There are important aspects like ecology, river for ecological processes, river for the entire fluvial processes, fluvial dynamics, corridors, groundwater recharge. लेकिन अभी वरुणा से ऐसा एक्सपेक्ट करना ऐसा नहीं है. पहले इसको हमको, जैसे एक मरीज आता है अस्पताल में, तो पहले हम उसको रिवाइव करने की कोशिश करते हैं, थोड़ा बहुत दवा देके, फिर लॉन्ग टर्म ट्रीटमेंट चलता है. तभी शॉर्ट टर्म में हम ये कर सकते हैं कि पहले रिवर को कहीं कहीं पे हम वेडिंग स्टैंडर्ड्स का बनाएं, नेविगेशन पॉसिबिलिटीज बनाए कि छोटे नाव चल सके, और फिशिंग जो लोग करते थे उसको फिर से दोबारा इस्टेब्लिश करें. और इसके लिए हमें ज्यादा पानी की जरूरत नहीं होती. जैसे अगर आप वेडिंग की बात करें तो वी नीड एटलीस्ट 1 मीटर वाटर, 1 मीटर पानी चाहिए हमको डेप्थ के लिए. नेविगेशन क्लास 1 रिवर सिस्टम्स के लिए करीब 1.2 मीटर पानी चाहिए, और फिशिंग के लिए भी करीब 1 से 1.5 मीटर पानी रहेगा सालों भर, तो हम उसमें फिशिंग भी कर सकते हैं. नाउ हाउ टू गो फ्रॉम जेनरिक टू साइट स्पेसिफिक. ये तो मैंने बहुत जेनरिक चीजें बताई हैं, लेकिन वरुणा को आप देखेंगे तो आपका सारा विज्ञान जैसे लगता है वहां पे फेल होने लगता है कि नदी में पानी कैसे लाया जाए. जब एक तरफ आपके करोड़ों लोग पानी निकाल रहे हैं, दोहने वाले लोग, और दूसरी तरफ आप नदी में पानी लाने की बात कर रहे हैं, तो एक बड़ा अजीब सा लगता है. आप एक ऐसे मुहाने पे खड़े होते हैं कि जब दुनिया आपकी तरफ देख रही होती है और आप कुछ कर नहीं पाते. तो लेट अस टॉक अबाउट कि साइट स्पेसिफिक हम कैसे करें. जैसे भी इन्होंने फ्लो रिलीज की बात करी कि हम अगर 150 क्यूसेक्स पानी हम ज्ञानपुर पंप केनाल से छोड़ दें तो नदी का थोड़ा बहुत भला होगा. और ऐसा नहीं कि पहला एग्जाम्पल होगा. मैं बताना चाहता हूँ कि गोमती नदी में लखनऊ में एक स्टैंडिंग ऑर्डर है गवर्नर से कि बेहता जो मधोइया स्केप है शारदा केनाल का, गोमती में 100 क्यूसेक्स पानी छोड़ा जाए. पहले तो समर में होता था, अब सालों भर हो गया है कि हमें 100 क्यूसेक्स पानी जो है हमको शारदा सिस्टम से छोड़ना होगा. इसी तरह बहुत ऐसे रिवर, ऐसा नहीं कि हम केनाल से नहीं छोड़ सकते. अरे केनाल के टेल एंड को हम वापस नदी में ही जोड़ दें, तो जो पानी हमारा वैसे तो रिचार्ज हो ही रहा है, लेकिन हम वापस नदी को दोबारा हम रिवाइव कर सकते हैं. सो देर आर साउंड एविडेंस बेस्ड प्रिंसिपल्स फॉर साइट स्पेसिफिक e-flow systems, and those are based upon 3 principles. पहले तो हम लैंडस्केप पर्सपेक्टिव लेते हैं, जियोमॉर्फोलॉजी लेते हैं, फ्लूवियल डायनेमिक्स लेते हैं, फिर कैचमेंट स्पेसिफिक इनसाइट्स लेते हैं, कि भाई ग्राउंड वाटर और उसके कैचमेंट के बीच, सरफेस फ्लो ग्राउंड वाटर के बीच क्या इंटरेक्शंस है, और रेस्टोरेशन जो चेक एंड बैलेंस की बात उन्होंने बताई कि हमारे वियर से खराब हो रहे हैं और जो चेक डैम से, ये भी हमें देखना पड़ेगा। लॉन्ग टर्म स्टडी अभी जैसे बुंदेलखंड वगैरह में हो रहे हैं, तो मेरा ये मानना है कि पहाड़ों में जहाँ पे इरोजन ज्यादा है, स्प्रिंग्स को उसको रिवाइव करने का यही एकमात्र तरीका है कि पानी को थोड़ा उसके रन ऑफ को कम करिए। लेकिन अभी इसमें हम छोटे छोटे स्ट्रीम्स में हम इसको कर सकते हैं। तो ये जो ई फ्लो फ्रेमवर्क हमने बनाया है, दिस लुक्स वेरी कॉम्प्लिकेटेड बट इट इज वेरी सिंपल। वी डू बैकग्राउंड इको हाइड्रोलॉजी बनाइए आप पहले, क्या है वहाँ का रिवर इकोसिस्टम कैरेक्टरिस्टिक, फ्लो रिजिम क्या है, ह्यूमन वेलफेयर ऑब्जेक्टिव क्या, जो मैंने आपको 3 बताए थे कि नदी को नहाने लायक और नेविगेशन और मछली के लायक बना दो। उसके बाद और भी सिनेरियो हम बना सकते हैं कि क्या हम क्लाइमेट चेंज होता है या पानी अचानक कम हो जाता है या बढ़ जाता है, उसमें हम क्या कर सकते हैं। और फाइनली हम एडेप्टिव मैनेजमेंट कर सकते हैं कि अगर फ्लो रिजीम को हमको ठीक करना है तो कैसे हम अडेप्ट करें सिस्टम्स को। पानी हमें हमेशा नहीं मिलने वाला कि अगर हम ज्ञानपुर पंप केनाल से दे तो ये परमानेंट सिस्टम होगा, हमें और भी चीजों पे काम करने पड़ेंगे, हमें सोशल इम्पैक्ट्स पे काम करने पड़ेंगे, हमें इकोनॉमिक एफिशिएंसी पूरे सप्लाई चेन पे काम करना होगा। तो खैर ये सब है, ये सब थ्योरेटिकल बातें हैं, बहुत सारी मेथड्स हैं, आई विल नॉट गो इनटू डिटेल, दीज आर दी मेथड्स दैट वी हैव डन, बिल्डिंग ब्लॉक मेथोडोलॉजी, देन फ्लो इकोलॉजी रिलेशनशिप्स, ये इसके बारे में शायद पहले स्पीकर ने बताया था कि जो 3 प्रिंसिपल्स हैं, ये एंजिला आर्थिंगटन है जो सी इज डूइंग ए वंडरफुल वर्क एंड जो इन्होंने पहली बार इसको दिया था। होलिस्टिक मेथोडोलॉजीज भी आ रहे हैं फ्लो मेथड्स के। ड्रिफ्ट अगेन आई विल नॉट गो इनटू डिटेल बट लेट मी कम बैक टू वरुणा रिवर। दिस इज द ओल्डेस्ट लिविंग सिविलाइजेशन इन द वर्ल्ड। काशी के बारे में बात करते हैं और वरुणा के बारे में बात करते हैं तो आपको बहुत प्राउड फील होना चाहिए कि वरुणा का जो फ्लूवियल इंसीजन हुआ था, दैट हैपेंड इन प्लेस्टोसीन होलोसीन पीरियड। इतने मिलियन ईयर्स पहले इसका फ्लूवियल गंगा प्लेन बना, उसके साथ वरुणा और अस्सी जैसी नदियां बनी और इतने सारे टेक्टोनिक इवेंट्स हुए जो कि नियो टेक्टोनिक्स, इधर खास करके जो लास्ट आइस एज हुआ था हमारा करीब 10 से 12,000 साल पहले, उसमें नदियों का बहुत चैनल फॉर्म, थोड़ा इधर उधर हुआ, नदी इधर बहती थी, इधर कुछ पैलियो चैनल्स इधर उधर हो गए, ऑक्सबो लेक्स बन गए, तो बहुत सारे चेंजेस हुए इस नदी में और अभी इसके सिग्नेचर हमें बहुत मिलते हैं। अभी आप उधर मछली बाजार से अभी मैं होके आया था पिछले सप्ताह, जब वाराणसी में प्रोग्राम था वाटर पॉजिटिव, तो जब मैंने बसुई रिवर को देखा मुझे इतना बढ़िया लगा, रिवर वॉज फ्लोइंग विथ लाइफ। मैंने आके ही प्रोफेसर पीके सिंह को फोन किया कि भाई बसुई रिवर में लाइफ है, हम लोग वरुणा को बचा लेंगे। बसुई और मोरवा को देखते हैं आप तो आपको थोड़ी सी एनर्जी आती है कि अभी भी नदी में जान है। और जो इंटरफ्लू रिवर्स होते हैं, खासकर 2 नदियों के बीच, अगर आप ये वरुणा रिवर बेसिन को देखें तो एक तरफ आपका गोमती रिवर बेसिन है इंटरफ्लू, इधर आपका छोटी सी आपका एक तो गंगा तो है ही, गंगा रिवर सिस्टम, और इधर गोमती, तो गंगा और गोमती का जो इंटरफ्लू रीजन है उसमें बहुत सारे ढेरों मॉर्फोमेट्रिक चेंजेस हुए हैं और आज जो नदी दिख रही है वो कालांतर में उसमें बहुत परिवर्तन हुए हैं। और ये जो बल्जिंग आपको दिख रहा है, पेरिफेरल बल्ज, इस बेसिन में हुआ क्या कि एक तरफ विंध्यन रॉक्स थे और दूसरी तरफ गोमती बेसिन, तो इन्होंने इतने सारे मॉर्फोमेट्रिक चेंजेस करे कि आज जो नदी का जो शेप आप देख रहे हैं which was very different at earlier times. So let me come back to the flow. So this is the Basui river और ये आपका मोरवा रिवर है। ये करीब जब ये 70 से 80 किलोमीटर जब ये फ्लो कर जाती है आपकी जो वरुणा रिवर है, तो ये 2 नदियों का मिलन होता है और बहुत सारा इसमें फ्रेश वाटर आता है। Now the Varuna river basin has many tals, ponds, meanders, scars, oxbow lakes और बसुई रिवर इसकी सबसे बड़ी ट्रिब्यूटरी। हमको इस पे काम करना होगा। अगर हम इन ताल, पॉन्ड्स, वाटर बॉडीज को, मैं बार बार कहता हूँ कि इन सबको वाटर सेंचुरी ट्रीट करना होगा, चाहे मनरेगा के विभाग हो या ब्लॉक डेवलपमेंट ऑफिसर हो, कि आने वाले समय में ये जो इसके जो लंग्स हैं, जो इसके किडनीज हैं, ये अगर खराब हो गए तो वरुणा को हम कभी भी बचा नहीं सकते। जो इसका मास्टर, जो हमारा मास्टर ड्रेन है 4th ऑर्डर स्ट्रीम है, लेकिन ये जो 2nd और 3rd ऑर्डर स्ट्रीम से, इसको बचाना बहुत जरूरी है और इसके हेड स्ट्रीम्स को। तो आप देखेंगे कि यहाँ पे बहुत सारे आपको छोटे छोटे वाटर बॉडीज और बड़े वाटर बॉडीज भी दिखेंगे जो बहुत सारे पानी लाते हैं। ये तो आपका डैम है। बेड स्लोप भी काफी कम स्लोप मिलता है, इसलिए रिवर का फ्लो काफी स्लगिश है। आप देखेंगे कि पूरे 225 किलोमीटर के स्ट्रेच में हमें जो आपका स्लोप मिल रहा है वो करीब 0.21 मीटर पर किलोमीटर है और पूरे स्ट्रेच में हमको केवल 47 मीटर का स्लोप मिल रहा है। रेनफॉल भी ठीक ठाक है, 800 मिलीमीटर है। रन ऑफ कोफिशिएंट भी अगर हम ले 0.30, तो हमारा वाटर डिस्चार्ज जो है करीब 75 एमसीएम के करीब आता है। पूरे रिवर कॉरिडोर की विड्थ की बात करें तो हमारे पास अच्छा खासा रिवर कॉरिडोर का विड्थ है जिसको हम बचा सकते हैं। अगर लैंड रेवेन्यू डिपार्टमेंट अभी भी नदी का डिमार्केशन कर दे तो नदी के जो दोनों टेरेस हैं उसको हम बचा सकते हैं। तो अब हम फ्लो की बात करते हैं कि दो हमारा ऑब्जेक्टिव है। ये वरुणा की अगर बात करें, ये हमारा 2003 का मान लीजिए आपका डिस्चार्ज है, और ये हमारा अभी जो मॉडिफाइड आपका फ्लो पैटर्न जो अभी बाद में दिखाऊंगा, तो इसमें हम ये कर सकते हैं कि जो हमारे लीन सीजन के हैं, जो जनवरी, फरवरी, मार्च, अप्रैल और इधर नवंबर, दिसंबर, करीब 5 से 6 महीने के टाइम जब पानी बिल्कुल नहीं होता है, तो हम उसमें फ्लो रिलीज की बात कर सकते हैं। अब ये देखें कि आपका इसका जो चैनल फॉर्म है काफी इंसाइज्ड है, बहुत बढ़िया बना है। कहीं कहीं पे तो 5-6 मीटर इसका डेप्थ है, और आज भी बहुत सारे लोग नेविगेशन में यूज करते हैं, देयर इज अ लॉट ऑफ पोटेंशियल। कहीं कहीं पे पानी की नेविगेशन पॉसिबिलिटी कम है, लेकिन अगर पानी आएगा तो लोग नाव भी चलाएंगे, ये कॉन्फ्लुएंस है। लेकिन अभी इसको कुछ लोग मतलब बिल्कुल नाले की तरह ट्रीट कर रहे हैं। एंड आई वाज गोइंग थ्रू दी डेटा, एक रिपोर्टर ने कभी आर्टिकल छापी कि 152 एमएलडी वेस्ट वाटर वरुणा के थ्रू गंगा में जा रहा है। जब हमने जल संस्थान से कांटेक्ट किया, जल निगम से, तो इसका फिगर करीब 54-55 एमएलडी आ रहा था। तो कई बार क्या होता है कि जब पीक मानसून में जो फ्लशिंग फ्लो होता है, जैसे आप इधर कुकरेल का देख लें या इधर लखनऊ में या हैदर कैनाल का, तो इतना 180-250 तक एमएलडी फ्लो हो जाता है। तो ये सबके सब आपके सब नदी में ही आते हैं, इसलिए wastewater dilution possibility should be looked into account when you talk about e-flows. Now another aspect is this river has already been identified as national waterway number 108. ये बहुत आश्चर्य की बात है कि एक तरफ आपने तो इसके 53 किलोमीटर आइडेंटिफाई किए, लेकिन जब मैं अभी एक एनजीटी का डॉक्यूमेंट पढ़ रहा था तो उसमें पहली बार वरुणा को नॉन पेरेनियल रिवर लिखा गया है। उसमें लिखा गया कि वरुणा तो भाई ये तो सीजनल रिवर है, इसलिए हम पानी नहीं ला सकते। ये समस्या पहले से। तो एक तरफ आप ये बता रहे हैं कि ये नॉन सीजनल रिवर है, दूसरी तरफ आप नेशनल वाटरवेज भी बनाना चाहते हो, तो हमको दोनों गोल को देखना पड़ेगा कि हम पानी इसमें लाएं कैसे। तो अगर हम इसके पॉसिबिलिटी की बात करें तो हम देखते हैं कि इसमें एवरेज जो हमारा विड्थ है करीब 42 मीटर का विड्थ इसमें मिल रहा है वरुणा रिवर। डेप्थ भी हमें करीब 1.5 मीटर मिल रहे हैं, जिसमें कि हम 1 से 1.25 मीटर पानी तो हम हमेशा रख ही सकते हैं। आपका बॉटम विड्थ भी अच्छा खासा मिल रहा है। कहीं कहीं पे हमें ड्रेजिंग करने पड़ेंगे, ड्रेजिंग इज रिक्वायर्ड एंड आई विल कम टू दैट पॉइंट। जो हमारा जो आप देखेंगे कि मैक्सिमम डेप्थ जो है कहीं कहीं पे हमें 7.3 मीटर भी मिल रहा है, तो अच्छा खासा इसका चैनल फॉर्म अभी बना हुआ है। ये कुछ क्रॉस सेक्शंस हैं जो आप देख सकते हैं। तो इस क्रॉस सेक्शन को देखते हुए आपको ये करना है कि जितना आपका इसका टॉप विड्थ है और बॉटम विड्थ है और जितने आप इसमें पानी स्टोर कर सकते हैं, उसके हिसाब से यू कैन कैलकुलेट दी फ्लो वॉल्यूम। अगर आपके पास डिस्चार्ज डेटा नहीं होता है, खासकर ऐसी रिवर्स का जहाँ पे गेज साइट्स नहीं बने हैं, जहाँ पे आपका रेगुलर डेटा नहीं मिल रहा है, then you can do some back of the envelope calculations, and depending upon the cross section and the 3 objectives that I shared, bathing, navigation and fishing, उसके लिए हमको 1.2 से 1.5 मीटर पानी कैसे आएगा इसके बारे में सोचना है। अब आपके पास सब कुछ है, सब मटेरियल तैयार है, आपकी अच्छी क्रॉस सेक्शन है। आपको करना ये है कि पहले वेस्ट वाटर के इम्पैक्ट को कम करना है, जो इसमें डाइल्यूशन पॉसिबिलिटीज कम हो, नदी की थोड़ी इकोलॉजी अच्छी हो, फिशिंग पॉपुलेशन बढ़े। और दूसरी बात, फ्लो ऑगमेंटेशन कैसे करना है। फ्लो ऑगमेंटेशन करने के लिए ये तो आपकी डेप्थ प्रोफाइल है। मैं रेनफॉल की बात बता रहा था इनको, हमारे स्पीकर ने बताया कि रेनफॉल के साथ इसका पैटर्न अभी खराब नहीं हुआ है। जैसे रेनफॉल है, रन ऑफ भी आ रहा है, लेकिन आप देखिए कि साइक्लिक पैटर्न्स दिख रहा है। ये पूरे विश्व में ऐसा होता है कि आपका एक डिकेडल ड्राई फेज चलता है, फिर वेट फेज आता है। नदियों के साथ भी अमूमन ऐसा ही हो रहा है, लेकिन स्टिल वी गेट एन एवरेज ऑफ अराउंड 800 to 850 millimeter of rainfall, and if we catch the rain where it falls through the various natural storages, we don't have to create artificial storage. इतने ज्यादा वाटर बॉडीज हैं, कई सारे पॉन्ड्स हैं, जो कि जिसका एरिया 10-10 स्क्वायर किलोमीटर है। और ये तो एनुअल फ्लो साइकिल है, मैं अभी डिटेल में नहीं जाऊंगा। मैं आपको ये बताना चाह रहा हूँ कि यहाँ ये देखिए 2003 और 14 में क्या फर्क हुआ, ये आप देखिए इसके अगर हाइड्रोग्राफ को आप देखेंगे या पूरे जो एवरेज डिस्चार्ज की बात करेंगे तो आप देखिए कि जनवरी के महीने में आपका मैक्सिमम डिस्चार्ज ये 2003 का है ब्लू वाला, और ये रेड वाला 2014 का है। अब ये जो इतने ड्रास्टिक चेंज हुए, ऐसा नहीं कि रेनफॉल हमारा इतना ज्यादा कम हो गया, हुआ क्या कि ग्राउंड वाटर टेबल कम हुआ और एब्स्ट्रैक्शंस और एलोकेशंस बढ़ गए हमारे जो अर्बन स्ट्रेच में जितने सारी पंपिंग हुई। तो मैं यहाँ पे फाइनली एक चीज बताना चाहता हूँ कि हमें जो 1.5 मीटर पानी चाहने के लिए पानी तो बहुत चाहिए, 150 हमने पहले कैलकुलेट किया तो करीब 550 क्यूसेक्स पानी चाहिए। अब 550 क्यूसेक्स पानी कहाँ से आएगा? 22,000 क्यूसेक तो हम गंगा में ही छोड़ते हैं। आपका जो ज्ञानपुर पंप केनाल है या फिर आपका शारदा दक्षिण जो आपका केनाल है, जो जौनपुर वाला ब्रांच है, जो उसमें भी इतना पानी नहीं है कि आप इतना 550 क्यूसेक पानी दें। तो अभी मैं ये कहना चाह रहा हूँ कि अगर हम ज्ञानपुर पंप केनाल से वरुणा में अपस्ट्रीम में ऑगमेंट करें, शुरुआत में 100 से करें या 150 से करें, और धीरे धीरे अगर हम पानी को बढ़ा सके, अगर पानी है तो इवन आजकल तो इसमें क्या हो रहा है कि मानसून में भी पानी कम है, तो जब मानसून में फ्लो है तो मानसून में छोड़ेंगे, इससे नदी की इकोसिस्टम भी मानसून में जो वेट फेज होगा, वेट फेज में हमारे शैलो एक्विफर्स बढ़ेंगे। जो ये रिवर जो अभी जो लूजिंग स्ट्रीम है, लूजिंग स्ट्रीम देते देते जो इसका कैचमेंट है उससे ग्राउंड वाटर टेबल भी बढ़ेगा अगर हम एक्स्ट्रा फ्लशिंग फ्लो को बढ़ाते हैं इस नदी में। और अगर आप देखें कि पुराने पुल बराज जो भी बना है करीब जहां से कॉन्फ्लुएंस होता है उससे करीब 5 किलोमीटर ऊपर, यहाँ से हम फ्लो को रेगुलेट कर सकते हैं। अगर हम चाहें तो हम 1.5 मीटर पानी की पॉन्डिंग करें। पॉन्डिंग हालांकि मैं अच्छा नहीं मानता इसे, लेकिन चूंकि नदी की ऐसी स्थिति है अभी, तो अभी तो पहले हमें उसके ट्रीटमेंट के बारे में बात करना पड़ेगा। तो अगर हम यहाँ पे इसके पुराने पुल बराज के पास हम इसके लेवल को मेंटेन रखें और कम से कम 5-10 सालों तक देखें कि इसका इम्पैक्ट क्या हो रहा है। इसका एक बुरा असर ये हो सकता है कि अगर आपने वेस्ट वाटर को नहीं रोका तो नदी में एनॉक्सिक कंडीशंस होगी और ग्राउंड वाटर पॉल्यूट होगा और आपको बार बार फ्लश करना पड़ेगा। ऐसा कई अर्बन स्ट्रेच में देखा जाता है। तो आपको क्वालिटी भी ठीक करना है। ई फ्लोज का मतलब ये नहीं कि केवल क्वांटिटी की ही बात हम करेंगे। और जो हमारे कई सारे घाट्स हैं, जो बैदिंग घाट्स है, मैं देख रहा था कि सिकरौल घाट, तरिया घाट, मस्जिदिया घाट, रामेश्वर घाट, लाल बहादुर शास्त्री घाट, सुरबा घाट, ऐसे कई घाट है जहाँ पे लोग आज भी नहाते हैं। खासकर जो हमारे जो स्पेशल रिलीजियस डेज होते हैं, जैसे अभी पिछले दिनों जो फुल मून था, शरद पूर्णिमा या कार्तिक पूर्णिमा या अभी छठ का पूजा होगा, तो अगर हम कुछ स्पेशल रिलीजियस डेज में भी अगर कुछ इंश्योर कर सके, ऊपर से हम पानी छोड़े, हालांकि इतना जल्दी तो आएगा नहीं, कई बार पानी पहुंचने में ही 5 से 6 दिन लग जाते हैं अगर हम उसका स्ट्रेच लंबा हो, और बहुत अगर एक्विफर्स में पानी स्टोरेज की कैपेसिटी हो तो कई बार तो वो तो बिल्कुल लूजिंग स्ट्रीम बन के पहले शैलो एक्विफर्स को भरता रहेगा और धीरे धीरे हमारा पानी का लेवल भी बढ़ेगा। और इस तरह अगर हम सरफेस वाटर ग्राउंड वाटर को मिलाएंगे तो हम एटलीस्ट 1 मीटर डीप वाटर इंश्योर कर सकते हैं फॉर बैदिंग रिक्वायरमेंट। और ड्रेजिंग जो मैं बता रहा था कि जो शैलो पैच है वो बहुत दिख रहा है, पूरी की पूरी नदी जो है सिल्ट से भरी पड़ी है। और हालांकि सिल्टिंग का बड़ा इम्पैक्ट होता है लेकिन हमें करना पड़ता है डीसिल्टिंग। तो डीसिल्टिंग और ड्रेजिंग अगर हम करेंगे तो एक तो इससे क्या होगा कि चैनल का डेप्थ भी बढ़ेगा, थोड़ी नेविगेशन पॉसिबिलिटी भी बढ़ेगी। अभी 50 किलोमीटर की बात करें हम, हो सकता है 150 किलोमीटर तक नेविगेशन बना ले, और इससे हमारा ग्राउंड वाटर सरफेस वाटर कनेक्टिविटी भी बढ़ेगा। तो मैं इतनी बात करना चाह रहा था। आई थिंक I don't know how to. So I hope I made my points clear. So if you have any question, you can come back to me. I think हमें 2-3 बातें जो वीके निरंजन साहब बता रहे थे कि एक तो हमें जो रोड्स और वाटर शेड्स बन रहे हैं, कल्वर्ट नहीं बनाते, ये बड़ी समस्या मैं देख रहा था कि पूरी की पूरी टेढ़ी रिवर जो आपने बताया सर, वो नेशनल हाईवे बना, एक रोड बना दिया, कल्वर्ट ही नहीं बनाया, पूरा वाटर शेड खराब हो गया। तो ये चीजें ना हो, मनरेगा के लोग इसको ध्यान रखें। और जो हमारा जो वाटरशेड अप्रोच है, लैंडस्केप अप्रोच है, उसको लेते हुए अगर हम रिस्टोर करें, रिवर रिस्टोरेशन करें, तो हम वरुणा में कुछ उम्मीद बाकी है। ऐसा नहीं है कि वी आर स्टैंडिंग एट द टिपिंग पॉइंट एंड वी कैन मेक दिस रिवर नेविगेबल, फिशेबल एंड स्विमेबल। थैंक यू सो मच। और अगर आपके पास कोई सवाल हो तो आप पूछ सकते हैं, अदरवाइज देन विल
Professor Datta, can I add something here?
श्योर।
One of the observations, especially क्योंकि नमाम गंगे के भी ऑफिशियल्स यहाँ पे हैं, तो जैसे मनरेगा में जब हम सेक्शन को ठीक करते हैं, दैट्स वेलकम, दैट्स ए फर्स्ट स्टेप कि कम से कम नहर का सेक्शन रिस्टोर हो। लेकिन उससे जो निकली मिट्टी है वो हम बैंक्स पे ही छोड़ देते हैं। तो वो जो चूंकि रिवर इज सपोज टू बी इन द एट द लोएस्ट पॉइंट ऑफ दिस कैचमेंट, तो जो पानी आता है वो सीधा उसमें इट हैज टू कम टू द रिवर वैली ड्यूरिंग द मानसून सीजन। तो वो जब वो मॉन्ट्स वहाँ इकट्ठे हो जाते हैं तो उसको वो बाधित करता है। तो मनरेगा से जब भी कभी रिवाइवल हो तो उसका जो डिस्पोजल है, जो निकली हुई सिल्ट है, उसका डिस्पोजल इस तरह से हो कि कैचमेंट का एरिया एक तो बाधित ना हो, और दूसरा ये जो अभी आपने कहा कि जो कलवर्ट्स हैं, कलवर्ट्स की जो कमी के कारण हमारा जो बाधित होता है, आई रियली टेल यू, आई हैव सीन सच एग्जाम्पल। इंडो नेपाल बॉर्डर पे हमारी एक बॉर्डर रोड्स बनी है, दिस वेरी इंपॉर्टेंट फॉर द सिक्योरिटी ऑफ द कंट्री, लेकिन उसमें हमारी राप्ती मेन कैनाल भी हम लोगों ने बनाया है। तो राप्ती मेन कैनाल जहाँ बनाया है तो नेपाल साइड से जो ड्रेन्स आ रहे हैं उसमें वी हैव स्टडीड इन डिटेल, और उसके बाद उसका क्रॉस ड्रेनेज वर्क बनाया है। लेकिन रोड्स पे इतने छोटे कर्वर्ट्स बने हैं करस्पॉन्डिंग उसी सेम ड्रेन पर कि दे आर वेरी सम 2 or 3% ऑफ द डिस्चार्जिंग कैपेसिटी। उसके कारण हर साल वो रोड कटता है। तो जो भी डेवलपमेंट से संबंधित अगर यहाँ कुछ हो तो उसको जरूर देख लेंगे कि कलवर्ट जो हमारे बने कैचमेंट एरिया में वो ड्रेनेज बाधित नहीं होना चाहिए। ड्रेनेज मेरे ख्याल से सबसे ज़्यादा निगलेक्टेड रहा है डेवलपमेंट में, और बाद में जब पता चलता है कि इसके इफेक्ट्स जो है बहुत बाद में आ पाते हैं, तब तक बहुत देर हो चुकी होती है। इस सब के साथ जो अभी आपने बहुत इसमें अच्छे इनपुट्स दिए, with this I think if anyone wants to add and take on the discussion further, all are welcome.
Now the floor is open for discussion. If you have any question, please raise your hand or maybe you can start speaking. अगर आपका कोई कमेंट हो या फीडबैक हो।
निरंजन सर एंड दत्ता सर, आपने बहुत ही अच्छा इंसाइट व्यू दिया हमें वरुणा का। इतना डीपली हमें भी नहीं मिल पाता क्योंकि हम बहुत सारी और चीज़ों से एंगेज होते। थैंक यू सो मच फॉर ऑल दिस नॉलेज एंड आई हैव गॉट वेरी मच एनरिच्ड विद दिस। लेकिन इसके साथ सर, जैसे जो आपने एक समस्या भी बताई कि मनरेगा में जो डिसिल्टेशन या ड्रेजिंग होती है उसके बाद वो वापस ही मॉनसूनल सीजन में वापस ही रिवर तक पहुंच जाता है। तो इसके लिए जैसे यूपी इरिगेशन डिपार्टमेंट काम करता है, यूपी एग्रीकल्चर डिपार्टमेंट, अगर क्योंकि ये जो सिल्ट होती है अगर आसपास कोई इंडस्ट्रियल एरिया नहीं है तो आई एम श्योर ये बहुत बेनिफिशियल होगा न्यूट्रिएंट पॉइंट ऑफ व्यू से, that can be used as a supplement soil for agricultural lands in the nearby area। तो अगर इसकी इस सिल्ट की टेस्टिंग करा करके नियर बाय, एक सिंपल टेस्टिंग करा करके नियर बाय एरियाज के लैंड फिलिंग या उन सब में यूज कर लिया जाए तो ये एक तो मनरेगा में एक और एडिशनल काम हो जाएगा। प्लस ये जो हमारी समस्या है वापस जाने का, जो हमारा सिल्ट उसमें इकट्ठा हो रहा है वो भी खत्म हो जाएगी। तो थोड़ा सा सिंक्रोनाइजेशन की जरूरत है और इतनी बड़ी समस्या नहीं है। बेसिकली हमें हर चीज एक दूसरे से लिंक्ड है और एक दूसरे से जोड़नी है। सो दिस कैन बी डन। तो ये मनरेगा में, क्योंकि मनरेगा में क्लोजली इरिगेशन डिपार्टमेंट भी काम करता है, तो वाइल जब ये सब काम हो रहे हो, बेसिकली मानसून सीजन से पहले ही होता है ये सब, तो उस समय अगर उसी वक्त ध्यान दे दिया जाए तो ये काम हो सकता है। सो दिस इज व्हाट माय सबमिशन इज।
राइट।
थैंक यू सर।
Do you have any more feedback? I think your point is quite valid. In fact, we have been saying that let's make Mahatma Gandhi National Rural Guarantee Scheme as the land and water restoration scheme. Now, this is the world's biggest employment generation scheme. अगर हम थोड़ा सा पॉलिसी लेवल चेंज करें और इसको साइंटिफिकली, इट इज ऑल प्लेइंग विथ लैंड एंड वाटर। आप देखिए मनरेगा के जितने वर्कर्स हैं सब सॉइल और वाटर पे काम करते हैं। What we have to do, we have to develop the proper guidelines कि कहाँ पे करना। अब देखिए कि केनाल जो अभी तालाब खोद रहे हैं वहीं पे मिट्टी डाल दें। उनको पता नहीं है कि इसका जो एक्चुअल जो सॉसर शेप होता है, जो तवा की तरह होता है तालाब, एक तरफ दोनों आउटलेट इनलेट खुले होने चाहिए, ये सब नहीं कर पाते, मिट्टी वहीं डाल देते हैं। केनाल की भी जो जैसे सफाई किया भी, तो वहीं पे सब मिट्टी डाल दिया, तो एक सीजन में तो चलिए, दूसरे सीजन में वापस फिर से आपके सिल्ट वापस आ जाएंगे। अभी यहाँ पे क्या हुआ था कि बुंदेलखंड में देयर वाज दिस अपना तालाब अभियान, वेयर पीपल वेर गिवन इंसेंटिव कि आपको हम जेसीबी फ्री में देते हैं, हमें मिट्टी दे देना। और हुआ क्या था कि वहाँ पे कुछ हाईवेज और रोड्स बन रहे थे जहाँ पे मिट्टी की जरूरत थी, तो बहुत सारे एक्सप्रेसवेज बनते हैं, हाईवेज बनते हैं, तो यहाँ पे अगर हम सिंक्रोनाइज कर लें दोनों डिपार्टमेंट को, तो दोनों प्रॉब्लम सॉल्व हो जाएंगे। हमें टॉप सॉइल का भी लॉस बच जाएगा, जो हमें अच्छे क्लास 1 क्ले की जरूरत होती है कहीं पे, तो हम उसकी जगह हम इसको रिप्लेस कर सकते हैं। और प्रॉपर रेस्टोरेशन का जो प्रिंसिपल है, इकोलॉजिकल प्रिंसिपल्स, वो हमारे लाइन वर्कर्स को बताना हो कि आखिर जो हम नदियों को रिवाइव करने जा रहे हैं, कहीं ऐसा ना हो कि ये शुरू में एक सीजन में तो अच्छा दिखता है, अगर आप दोबारा जाके देखेंगे तो फिर से वही ढाक के 3 पात, या इसको बोलते पुनर्मूसको भव, संस्कृत में है ना, कि फिर से आप दोबारा आप जाके देखेंगे, तो वी हैव टू वर्क ऑन अ लॉन्ग टर्म रेस्टोरेशन प्रोसेस, एज DG Mishra ji was saying in the morning, that rejuvenation is not the river cleaning. Rejuvenation is science, restoration is a long term science which takes time. It is a feed forward loop. कहीं पे खराब हुआ तो मिड कोर्स करेक्शन करना है, हमें खुद सीखना होता है। बाद में कई बार तो हमने फील्ड में जाके सीखा कि जो हम नदियों को तालाबों को ठीक करते हैं उससे कितना डैमेज होता है। बायोटिक कंपोनेंट जो नेचर का जो फ्लोरा फौना है अपने आप हजारों लाखों साल के बाद ये फॉर्म में आया है। तो वी हैव टू डू मिनिमम इन्वेजिव, जैसे मिनिमम इन्वेजल सर्जरी करते हैं ना, कि कम से कम डॉक्टर लेप्रोस्कोपी से कर दिया, तो उस तरह के अप्रोच जहाँ पे हमें ले रहे हैं, जहाँ पे हमें रिगरस अप्रोच लेना है, जहाँ पे ओपन बाईपास करना, हमें ओपन बाईपास करना पड़ेगा, जहाँ पे लेप्रोस्कोपी करनी है वहाँ पे करना पड़ेगा। वी हैव टू बी वेरी साइट स्पेसिफिक, एवरी रिवर इज डिफरेंट, देयर इज नो specific, there is no type A river, there could be many types of rivers and they define the entire catchment। और कई बार तो नदी के beyond हमें काम करना, channel is just one mirror and we have to work on outside the channel, outside the catchment। So thank you Professor P.K. Singh ji and all these distinguished speakers in this session. We had a very good deliberations from the panel. We talked upon the restoration and the e-flow release, how to bring back water into the Varuna river. So I would suggest Professor P.K. Singh ji ki please make one committee, as Professor Tare was saying. It should be different than the district Ganga committee. It should be a restoration committee where people like Sri V.K. Niranjan ji should be there, where people like Manrega commissioner should be there, where people from academics should be there. Let us make it a very action-oriented committee, not just on the paper, but they should make a visit at least once in a 6 month। और जैसे इन्होंने बताया कि अगर हम शुरुआती में अगर 150 क्यूसेक्स पानी छोड़ दे तो ये तो हमारे लिए बहुत अच्छी बात होगी। हालांकि एज ए रिवर साइंस आई डोंट लाइक टू टेक उधार। अगर आप बताएंगे कि आप उधार ले रहे हैं, नदी के अंदर इतनी कैपेसिटी होनी चाहिए कि पानी खुद जनरेट करे। नदी का जो भोजन है वो ग्राउंड वाटर है। ग्राउंड वाटर, ये सारे ट्रॉपिकल रिवर्स के सोर्स ग्राउंड वाटर हैं। जब तक बेस फ्लो को हम नहीं ठीक करेंगे हमारी नदियां ठीक नहीं होगी। लेकिन शॉर्ट टर्म में हमको शैलो एक्विफर्स को भरने के लिए भी पानी चाहिए होता है, और अगर केनाल में अगर एक्स्ट्रा पानी है तो हमें उधार लेना पड़ेगा। थैंक यू सर। सर यू आर नॉट ऑडिबल, आपका स्पीकर म्यूट है।
Very nice. I saw a very detailed calculation and graphical representation of Varuna, its discharge, and as you have rightly told, groundwater remains the bigger contributor. But how to enrich it, or how to retain the larger portion of rainfall in the catchment, that remains on our target। And as you mentioned towards the end, उधार तो नहीं लेना है, लेकिन हम उसको इनरिच कर सकते हैं। और आज की तारीख में हमारी आवश्यकता थोड़ा उसी प्रकार की हो गई है। एक बार को कुछ समय के लिए अगर हम अपने, और जैसे आपने पुराना पुल का एग्जाम्पल दिया, उसके बैराज का एग्जांपल दिया, अगर उसको यूज करते हुए हम थोड़ा सा ग्राउंड वाटर को इनरिच करते हैं एंड रिटेन करते हैं, तो हमें लगता है कि इन द नियर फ्यूचर along with the Manrega activity which we are already, I mean, closely discussing with that, if we can do that, I feel it can be done. We are not that far, and जो सेंट्रल पॉल्यूशन कंट्रोल बोर्ड और ये जो 32 किलोमीटर का जो जोन कह रहे हैं, जो थोड़ा क्रिटिकल जोन में दिखाई दे रहा है, उसके लिए इस ये पुराना पुल का इस्तेमाल करते हुए थोड़ा अगर हम ई फ्लो को ऑगमेंट करेंगे, आई फील we will be in a better position to reach towards a solution. So let us start. And as far as this committee formation is concerned, you are in a better position. Your group has to recommend what we should do and how we should move forward. So this is an opportunity for all of us, and Engineer Niranjan is here, you are there, and the entire academia is there with you. The way you want us to act, we will be there. So please give your considered recommendation. What should be the stepwise movement for us? Thank you.
Thank you, sir. So we should now close this session with your permission.
Definitely, I will expect a very, I mean, tomorrow we are going to have a summary session in the afternoon, where we will be once again revisiting these recommendations from your group. And I feel Professor Datta will be one who will be representing on what is the recommendation for Varuna, how we have to move, at least in this environmental geology group. So I wish that Professor Datta and Sri V.K. Niranjan Saab, let us still be in good touch till tomorrow at least, so that your recommendation comes to us and how we are going to submit our, I mean, considered view, so that further plan of action can be devised. So Professor Datta, you have to summarize all and all kinds of suggestions which have come to us, and the kind of calculations you have made, and how we can move towards those objectives. Thank you.
Sure. Sure, sir. We'll do it tomorrow, and I'm looking forward to meeting you, all of you, again tomorrow. Thank you so much, sir.
बंदी हो गया ना